Hi kids, am I audible? Hello? Hi students, hi everyone. I hope you all are doing well. Am I perfectly audible and visible? Good evening everyone. Welcome to this most awaited session, Biomolecules, and today we are going to discuss carbohydrates and proteins in detail. So it is a marathon session, but again a detailed marathon session where we are going to revise carbohydrates and proteins. So excited? So you students were requesting now that ma'am please keep the test syllabus as per the All India mock test series. So that is why bache, we have decided that we will follow the same schedule. Okay, done? Happy? So let me tell you one more important thing, kids. I hope you are aware, but still let me tell you that now your All India mock test series is at a price of 999. So just click the link, add your number, add your email and be the part of this test series at a price of 999. Means in less than 1000 rupees you guys are going to get 20 plus tests plus the detailed discussion of these tests. And the questions here are amazing, right? NCERT based questions are there, assertion reasons based, statement based questions, everything is covered here in this test series. So be the part of this test series as soon as possible, right bache? Again it will come to the same price, that is 1499. So before that, join it now. Okay, join it now. Done? Ma'am, I'm 12th. I want to. Rakesh, it's your choice. If you want to, you can. Done, bache? So let's start the biomolecule. So are you all ready with your NCERT, with your notes, pen, paper, everything? Yes? Shiva Kumar, ma'am, even if I have joined the Avengers, but this is a different test series. It is not specifically for the Avengers batch students. It is a different test series. Anything else? Any other query? Then I'll start the lecture. Tell me if there is any other query. Just let me know. Ready? Okay, so let's start the chapter biomolecules. This chapter is important for your class 12th as well, right? If you master this chapter, class 12th molecular basis of inheritance, your DNA structure is going to be very easy for you. And trust me, this chapter is easy as well, right? Biochemistry is going to play a very crucial role in your MBBS. So whenever you study this chapter and you find it difficult, just focus on one thing, that you are preparing yourself for the MBBS. Isn't it? You are preparing yourself for the MBBS. Right, bache? Clear? So let's start the session biomolecules. So when you talk about the biomolecules, so as per NCERT, all carbon containing compounds are the biomolecules. What are biomolecules? All carbon containing compounds are biomolecules. Isn't it? Isn't it? Now when you talk about the living organisms, you can consider any living organisms, right? Like you know that we have even completed the classification part, right? You know it very well. So when you talk about the living organism, there is a diversity here, isn't it, bache? There is the diversity here, isn't it? We see the unicellular bacteria as well. We even see the single-celled eukaryotic organisms. You see the plants, the fungi, right? The animals, isn't it? Isn't it? So obviously diversity is there. Not all the organisms are same. Some changes are there here and there. This is what we have seen, right, bache? So you can take any living organism. You can take the bacteria, you can take the plants, you can take the animals. When you will check their chemical composition, when you will check their elements, you are going to get similar results. Okay. You can make the, like, let me write it here. You can consider the microorganisms. You can make the microbial paste. Okay, you can make the plant paste or the animal base. So you are going to get the similar result. similar results. And now similar results means similar type of chemical composition will be there, similar type of elements or the compounds will be there. Composition can vary, no doubt, composition can vary, but the compounds, the chemicals, they are going to be similar, right bache? And even when you compare these living organisms and their composition with the non-living matter, when you compare it with the non-living matter, like take the example of earth crust, again you will get similar list. Okay, so you can say that we all are formed from the, like our elders used to say, isn't it? Or any spiritual gurus, they used to say that we are made up of what? Right? That we all are also made up of the same things, right? It is the earth that is making everything. So yes, you can relate it here. Ultimately, the chemical composition is all same. Okay, the chemical composition is all same. So when you talk about the biomolecules, this is what you are going to study. You are going to talk about these organic molecules. You are even going to talk about the inorganic molecules. And in this chapter, in detail, we will be discussing carbohydrates, proteins, lipids, right? Nucleic acids, enzymes. Okay, this is what we are going to cover today. This is our target for today. Ready for it? Yes, bache? Are you guys ready for the session? Because many students were demanding it, ma'am, we want session on biomolecules, we want session on biomolecules. So quickly share the link with others as well, right bache? Just share this video link with your other friends as well and let them know that very amazing session is going on and you all should join it, right? Okay, so this is about the biomolecules. Clear bache? Now, obviously, as per the word also, bio means life, molecule means the molecules which are present here. So here it is from NCERT. You guys can see here that all the living organisms, they are made up of same chemicals, that is same elements and compounds. Clear bache? So as I said, analysis on plant tissue, animal paste, microbial paste will give you the same list of elements like carbon, hydrogen, oxygen, nitrogen and several other elements are there. So ultimately what is going to be there? Yeah, the carbon, hydrogen, oxygen and several other elements will be there, right bache? And they are present their respective content per unit mass. This is how we are going to calculate it. Any doubt? Yes, Nitya, any doubt here? So same analysis, as I said, when you will perform it on earth crust, which is non-living, again a similar list is obtained. Done bache? A similar list is obtained. Clear? Now, in the biomolecules, what you have to study? In the biomolecules, what you have to study? You need to study the two things: bio-micromolecules, bio-macromolecules. Bio-micromolecules, bio-macromolecules. This is what we are going to study. Micro and the macro. Micro and the macro. Now, bache, bio means living, molecules you know. Now the word is micro and the macro. Micro, which is in, yes, how can you define bio-micromolecules? Obviously, it is related to their molecular weight. It is related to what? It is related to their molecular weight. So bio-micromolecules are those having less molecular weight. Bio-macromolecules are those which are having more molecular weight. We are going to relate it, understand it, and even we will see the differences. But before understanding or reading it in detail, we should know the chemical composition, right? So the first thing that we need to study is how to analyze the chemical composition. Do you know how? Yes, everyone. Do you know how to analyze the chemical composition? I told you now that we need to make the paste and then we have to check. So this is the question, and even it is given in NCERT that how to analyze the chemicals, isn't it? How to analyze the chemicals. So now, take any living tissue, anything it can be. You can take the plant material, plant tissue you people can take, right? You can take the rat's liver, whatever it is. Just take any living tissue. What you have to do, bache? You need to take any living tissue. Now, put that living tissue in a mortar and a pestle. Okay? In the mortar and the pestle, of course. Now here, right, you are putting that living material. Now you have to add one acid. What do you need to do? You need to add one acid. and the name of that acid is your trichloroacetic acid. What you need to add here? You need to add here trichloroacetic acid. Right, what is it? Write it down in the chat section quick. What is it? Trichloroacetic acid. Trichloroacetic acid. You know about the acidic acid, isn't it? Acetic acid is your CH3COH. This is the acetic acid, na? CH3COH. Obviously, you are going to add what? Chlorine. Okay, and what will you get? You will get trichloroacetic acid. So it is going to be CCl3COOH, isn't it? It is going to be CCl3COOH. This is the trichloroacetic acid, and obviously it is stronger in comparison to the acetic acid. So this is what we are going to add here, right? So after adding it, obviously you will get a slurry. Okay, slurry means a kind of, you know, a kind of paste. A kind of paste. Like you have the living tissue, you are putting a liquid there, right? In the mortar and pestle, you are breaking the living tissue, then you are putting the acid there. So obviously a kind of paste you people are going to get, and we use the word slurry for it. Okay, we use the word slurry for it, right, bache? Now when you talk about this slurry, what we have to do in this slurry, but you tell me one thing, that why do we use trichloroacetic acid? Why do we use trichloroacetic acid here? Anyone? Why do we use trichloroacetic acid here? Any explanation? Let me tell you. When you talk about the trichloroacetic acid, as I said, it is a stronger acid than the acetic acid. But here, this is used in biochemistry, this trichloroacetic acid, because it is responsible for the precipitation of your DNA, RNA, proteins, okay, etc. So it helps in the precipitation of these macromolecules, right? And moreover, let me tell you, bache, this trichloroacetic acid, it is even used in cosmetic products. This trichloroacetic acid, like sometimes the genital warts are there, na? Genital warts, or any, if on our body, if warts are present. So yes, this trichloroacetic acid is used to remove it as well. Okay, it is used to remove it as well. So trichloroacetic acid, as I said, it is important for the precipitation of DNA, RNA, proteins, and etc. That is why in biochemistry, for the chemical analysis, this trichloroacetic acid is used. Clear, bache? This trichloroacetic acid is used. So now you are doing what? You are making a slurry. You are making a kind of paste. Now you are going to filter it out. Like here you have the slurry, right? You are going to take a cloth. Here you are going to put that paste, and then what will you try to do? You will try to filter it out. Okay, what will you try to do? You are going to filter it out. Are you getting my point? What will you do, bache? You are going to filter it out. Wait, let's say see, you are going to filter it out. So after filtering it, you are going to get two things. One is obviously your filter rate, right? Whatever you will get after filtration. See, here you will get filtrate, and whatever is remaining in this cloth, that will be your remaining portion. For that, you are going to use the word retentate. So this is your filtrate, and here you have the retentate. Clear, bache? These are the two words. One is the filtrate, and another is what? It is the retentate. Done. Now, there is one trick that you need to remember here. The trick is fast. What is the trick here? The trick is fast. Yes, everyone, write down this in the chat section and be quick. Be quick. Janan, it will be shared today, bache. Right? Fast. What is the word here? Fast. So F stands for filtrate. F stands for filtrate. A stands for acid. S stands for soluble. Okay, this is the trick. T stands for nothing. S stands for soluble. So fast it is. Filtrate, acid, soluble. Filtrate is acid soluble. I told you that you will get a paste here, you will get the slurry here, you are going to filter it out. So the filtrate is your acid soluble, and retentate is your acid insoluble fraction. This is what you need to understand first. Okay, retentate is your acid insoluble fraction and filtrate is what? It is your acid soluble fraction. Any doubt? Yes, any doubt here? Anyone having any doubt? Okay, so let's write it like this. So, living tissue, and please make the notes. Put it in mortar pestle. Add trichloroacetic acid. Then what will you get? You will get the slurry divided into two parts. Basically filter it out. One is the filtrate and another is going to be the retentate. So when you talk about the filtrate, now you know the trick as well. So filtrate is acid soluble fraction. Clear bache? And retentate is acid insoluble fraction. This is important. Now what will be there in the acid soluble fraction? In the acid soluble fraction you will get biomicromolecules, and in the retentate, that is acid insoluble fraction, you will get biomacromolecules. What are you going to get? You are going to get biomacromolecules. One is biomicromolecule, another is biomacromolecules. Now when you are talking about the biomicromolecules, bache, these are the biomolecules having molecular weight less than 1000 Dalton. Which molecules are biomicromolecules? Having molecular weight less than, yes bache, less than 1000 Dalton. Okay, Dalton is the unit here for this molecular weight. And when you are talking about the biomacromolecule, they are the macromolecule having molecular weight above 10,000 Dalton. In some books it is given as above 1000 Dalton as well. So basically you can say that above, if 10,000 Dalton, if there is something, right, then that will be considered as the biomacromolecule. Clear bache? That will be considered as the biomacromolecule. Clear bache? So here it should be above 1000, or in some books even it is written that it is above 10,000 Dalton. Okay. Done. So these are the biomacromolecules. Now when you are talking about the biomicromolecules, you people will get the monosaccharides here. Monosaccharides means single sugar. We will discuss it in detail as well. You will get the amino acids there. Amino acids are again the monomers which will form proteins. You will get the nucleosides, nucleotides here. They will help in the formation of your nucleic acids, right? So this is what you are going to get here in what? In acid soluble fraction. Now when you talk about the acid insoluble fraction, the molecular weight should be above 10,000 Dalton. So here we will see polysaccharides, right? Here you will see what? Polysaccharide. But you see the difference here. Mono means single, saccharide means sugar. Mono means single, saccharide means sugar, single sugar is there. So obviously molecular weight is less. Polysaccharide, poly means many sugars will be there. Above 10. So it is the polysaccharide. So obviously it is what? Biomacromolecule. So polysaccharides are there. Proteins, which are again the polymers, right, of amino acid. Nucleic acids, again the polymers of your nucleotides, right? This is what you are going to get. And yes, you will get the lipids here also, right? You are going to get the lipids also. What will you get here in the biomacromolecules? You are going to get the lipids. But there is one point that you all need to take care, that when you talk about the lipids, I'm writing it here, but lipids are biomicromolecules. They are not biomacromolecules, they are biomicromolecules. Do you know that? Yes, lipids are not the polymeric substance. They are not polymeric. Okay, they are not polymeric. They are biomicromolecules because their molecular weight is less than 8,000 Dalton. Okay, the molecular weight is less than 800, not 1000, 800 Dalton. Clear, bache? Clear, bache? Now the question arises here, Priyanka, that if they are the bio-micromolecules, then what are they doing here in the bio-macromolecules? Isn't it? Right? As I said that lipids, they are not polymeric, they are bio-micromolecules because their molecular weight is less than 800 Daltons. So what are they doing in this retentate? What are they doing in this acid insoluble fraction? Right? How is it possible to see one bio-micromolecule here in acid insoluble fraction? It is very simple. You know that these lipids, these phospholipids are also going to make our plasma membrane. If you talk about a living body, right, if you are performing the analysis of a liver, right, you can take the human liver, obviously, which is not allowed. You will go for the rat's liver. So what will you see here, right? You know that the lipids are going to make the plasma membrane. They are making the outer coverings, right? Adipose tissue is also protecting our body. It is meant for the, right, cushioning, isn't it? Isn't it? So when you talk about these lipids which are insoluble in water, and present in our body, right, making the coverings and all. So when we do this, when we try to make the paste, okay, so at that time what is going to happen? These lipids, they will break into some insoluble vesicles. What are they going to form? They are going to form some insoluble vesicles, and because of that, right, because of that insoluble vesicle, because of the formation of these insoluble vesicles, they will stay there in that acid insoluble fraction. Okay, done, bache? So this is important to know. Fine, it is important to know. Clear? Clear? Now, moreover, when you talk about this acid soluble fraction, do you know what it represents? Yes, what it represents. Now, bache, when you talk about a living cell, okay, you're talking about a eukaryotic cell. You know that we have the nucleus here, we have the organelles here. Yes or no? You know that we have the nucleus here, we have the organelles here, isn't it? And even the cytoplasm, the main arena of cellular activity, is also there. Yes or no? Yes or no? This is what a living cell is containing. Yes, bache, Shri, Harsha, Aarti, everyone. Of course. Now the point here is, when you are breaking a living tissue, ultimately you are breaking a cell, right? You are trying to separate their composition, isn't it? You are trying to separate their composition here. So when it is the acid soluble fraction, so what does it represent? It represents the cytoplasmic composition without organelles. Like, you are not considering the organelles here, you are not considering the composition of the organelles here. Whatever is that cytoplasmic composition, it is represented by this acid soluble fraction. And when you talk about the acid insoluble fraction, right, when you talk about the acid insoluble fraction is representing the cytoplasmic composition with the organelle composition, right, with the organelles as well. So together they are representing what? Together they are representing what? Together, acid soluble and insoluble, they are representing the composition of the cell. Is that clear? So I'm going to write it down. So acid soluble representing cytoplasmic composition without organelles composition. Done, bache? And when it is the acid soluble fraction, insoluble fraction rather, so it represents cytoplasmic composition with organelles composition, right, bache? Or majorly you can say that organelle composition. So together they are representing the composition of a cell. Clear, bache? Together they are representing the composition of a cell. So this is about the filtrate, about the retentate, about the bio micromolecules, about the bio macromolecules. Clear? So now I'll ask one question. May I out of the following, which one are the bio macromolecules? Okay, I'm giving you this question. So here, let me write down. You need to mention the bio macromolecules. Okay, bio macromolecules. Tell me, that's your question. And in one, right, in one message, I need the answer of this question. Quick. Which one of the following are the biomacromolecules? Everyone, please answer it. Quick. Yes, quick. Speed up, everyone. Just answer the question. Take your time and answer this question. It is important. Quick. I'm talking about the biomacromolecule. So, bache, if it is biomacromolecule, the molecular weight is going to be above 10,000 Dalton. So, out of the following, you need to know which one is a biomacromolecule. So, see, if you talk about the collagen is a protein. So, I told you proteins are biomacromolecules. Your DNA is a nucleic acid. It's a nucleic acid, again a biomacromolecule. Your heparin, it is also a polysaccharide. It will be there in that heteropolysaccharide, right? So obviously it is also a biomacromolecule. Galactose is your monosaccharide. So it is not a biomacromolecule. It is a micromolecule. Fructose, again same. It is also a monosaccharide. So again it is a biomicromolecule. Ribose, again biomicromolecule. It is adenine, again it is a nucleotide. So again it is what? It is again the biomicromolecule, right? It's a nucleotide basically. Guanine is also it is a nitrogenous base. It is a biomacromolecule. It's a nitrogenous base. It is also a nitrogenous base, biomicromolecule. Okay, so inulin is your polysaccharide, biomacromolecule. Insulin protein, biomacromolecule. Clear, bache? The stearic acid, it's a lipid. So definitely it will be your biomicromolecule. Trypsin, it is an enzyme. Biomacromolecule, it is. Carboxypeptidase is also an enzyme. So it is your nucleotide. So that is how you need to differentiate it. Okay. Galactose is not a disaccharide. Who taught you this? That galactose is a disaccharide? Seriously? Done, bache? So that is how you need to answer the questions. Clear? Okay, so here I have added few notes as well, so you guys can see the thick slurry is there. You need to filter it out with the help of cheesecloth. You'll get the two fractions. Okay, chaliye. So the next is elemental analysis. Do you know anything about the elemental analysis? As of now, we discussed what? We discussed the chemical analysis, and now what are we talking? We are talking about the elemental analysis. So it is not just the organic things are present in a living body. No, inorganic elements are also there, like your calcium, like your magnesium. They are also present in a living body. So what we have to do? What we have to do for that? We need to take a living tissue, right? Right, bache? We need to take a living tissue. Then what will we do to that living tissue? Tell me quickly. We will take the living tissue, right? So we, with the help of Ash analysis technique, right, we can perform this elemental analysis, right, bache? We can perform this elemental analysis with the help of this Ash analyzing technique. So what is going to be what we need to do here? We will take a living tissue, right? We will take a living tissue. Then what, bache? Then you are going to burn it. So because of that, what is going to happen? Yes, bache, Shri Harsha. Because of that, what is going to happen? Anyone? Living tissue. Obviously, you are going to take the living tissue, right? Right. So what will you do? What will you do here? First of all, bache, you need to check its wet weight. What do you need to check? You need to check its wet weight. Now, what is the meaning of wet weight? Basically, now when you will take a living tissue, it is also having the water. Right, it is also having the water. Now you are going to check its weight. That weight will be considered as wet weight because water is present, right? Water is present, and then after some time you are going to do what? You are going to evaporate that water, right? Evaporate that water, and then when you will check the weight, that weight will be your dry weight, right? That weight is going to be your dry weight. Okay, bache. And now when you are going to burn this tissue, what is going to happen? All the carbon will go out, right? It is going to form that oxides, it will go out, and then you will get that ash, and in that ash you guys can check the inorganic elements. Okay, you people can check the inorganic elements. Here you people can see. So dry piece of living tissue, right? Burn the tissue, ash is left behind, all carbon compounds, they turned into the gaseous form. I told you already, they turn into the gaseous form, right, bache? So content in ash is calcium, magnesium, sulfate, phosphate, and this is how we are going to perform the elemental this is how we are going to perform that elemental analysis. So when it is the chemical analysis, you go for that trichloroacetic acid test where you discuss micro and macromolecule acid soluble and insoluble fraction. When it is the elemental analysis or analysis of inorganic compound, this is what we need to do. We need to check the ash. Clear, bache? We need to check the ash. So any doubt here? Any doubt here? Yes? Any doubt here? If there is any doubt, do let me know. So add one more point here, right? That when you talk about this acid soluble fraction, here in this acid soluble fractions, you are going to find that sulfates, phosphates, etc. Clear, bache? Given in NCERT. So this is what you are going to get in this acid soluble fraction. You will get the sulfates, phosphates, etc. So I hope it is clear to you all, right? Chalo. So now let's revise it from NCERT quickly, and then we will start our next topic, that is primary and secondary metabolite. Fine. So here you guys can see how to analyze the chemical composition. So again the story is same. I will just right, again the story is same, and I am just going to mention the important points here. Just a minute, guys. Okay, so I'm going to mention the important points here only. So this is what you need to see. So here you people can see living tissue will be taken, okay, grind it in trichloroacetic acid using a mortar and pestle. So slurry will be obtained, divided into two fractions. So that is what we have discussed. So any doubt here? Any doubt here? So bache, here you are going to get the lectures where your NCERT will be, right, discussed. Okay, so we are going to check each and every line of NCERT. Okay, so while attending the session, always keep your book with you, and whenever I say that this point is important, they can ask you the question, NTA can ask you the question from this point. So highlight that in your book. Okay, highlight that in your book. Done, bache? So scientists have found thousands of organic compounds in the acid soluble pool, right? So now just look at this table. And here what they have mentioned, they are just mentioning the other techniques. We don't need it. So with the help of some techniques, obviously we'll separate these compounds. So analytic techniques, when applied to the compounds, they give an idea of molecular formula and probable structure, right? Right, so this is we don't want this. We need to focus here that all the carbon compounds that we get from the living tissue, they are the biomolecules. They are the biomolecules. Clear, bache? Clear? Now look at this table. Bache, question can come from this part as well. It is from NCERT, of course. It is from NCERT. So question can come from this part. So basically when you compare the earth crust, which is non-living, and the human body, which is living, right? So ultimately carbon, hydrogen, oxygen, nitrogen, this is what we are going to get. Now just look at this table. I'll tell you what kind of question they can ask. So now when you look at the non-living matter, that is your earth crust, the hydrogen and the oxygen. In the human body, look at the level of the hydrogen. So if you compare the non-living and the living organism, so you will see that in a living body, the amount of oxygen is maximum, and then comes the carbon, isn't it? Then comes the nitrogen, isn't it? And then comes your, yes, calcium, if we go as per this. And then after calcium, what do we have? After calcium, we are having this hydrogen, and then comes the sulfur, and then comes the magnesium, isn't it? Isn't it? Like if I compare the non-living and the living organism, so you will see the oxygen as maximum in the living organism, then followed by carbon, then nitrogen, calcium, hydrogen, sulfur, magnesium, and the silicon is negligible here, right? Silicon is negligible here. So yes, they can ask you these questions. Now when you look at this, right, non-living organisms, just have a look. So obviously again the maximum is your oxygen, isn't it? Maximum is your oxygen. And then see, look at this, the sodium, right? The calcium basically, then comes the calcium, then comes the sodium, then comes the magnesium. So when you compare these two, you will see in human body and in the earth crust the amount of nitrogen. So in the earth crust, in the non-living things, nitrogen is very little, and silicon is having the good amount, and that is negligible in the case of human body, in the case of living tissue. Clear, bache? Clear, bache? So they can ask you these type of questions. Ma'am, please tell me that NCERT Hanji, they are sufficient, Faisal. And bache, the spamming here in the chat sections of the teacher is also sufficient. Okay, keep doing it till NEET 2024. Definitely you will get selected for sure. Fine. Okay. Okay, so now the next is this. These are the representative inorganic constituents like sodium, potassium, calcium, magnesium, water, and the compounds are present. Obviously, we know these are present here. Okay, done, bache? So chemic elemental analysis gives elemental composition of living tissue in the form of hydrogen, oxygen, chlorine, and the carbon. And when it comes to the analysis for compound, if it will tell us about the organic and the inorganic constituents. Any doubt? Yes, bache, any doubt? Any doubt, yes or no? So the next that we need to study is primary and secondary metabolite. Okay, next what we need to study, see, when you talk about the biomolecules, when you study the biomolecules from the biology, right, class 11th, you know that this chapter is there in class 12th as well in chemistry. So in class 11th it is not given properly, like everything is mixed. Initially they are talking about all that things, and then suddenly they'll put the amino acid and the lipids, right? Then they'll explain about the proteins and then the polysaccharide, this and that, right? So it is not proper, it is not in a flow. So I'm going to teach you this chapter in a different flow, but after attending my sessions you can easily understand the NCERT. Fine, you can easily understand the NCERT. Done, bache? Done. So next that we need to study is what? It is the primary and the secondary metabolite. What is it? It is the primary and the secondary metabolites. Now you know that in a living body, chemical reactions are very common. Basically, we have studied the living organism and we know this, that metabolism is a defining property, isn't it? When you talk about the metabolism, what is it? It's a defining property of the living organism. Means there is no exception at all, isn't it? There is no exception at all. All the living organism, talk about the unicellular, talk about the multicellular, you can talk about any of the living organism, definitely metabolism is there in their body, the chemical reactions are there in their body, right bache? So when you talk about the metabolism, there are two words, one is catabolism and second one is anabolism. One is catabolism and the second one is anabolism. So when it is kata means cut. When it is kata means cut, and when it is ana means build up, isn't it? Ana means build up, isn't it? So cut and the build up is there. Cut and the build up is there. Yes or no? Cut and the build up is there, isn't it? So kata, cut, ana, build up, metabolism, chemical reactions are going on. There are one compound will get converted into another one will join, will form another one. So basically these chemical reactions are keeping us alive, because whatever we need for our survival, the energy, the food, everything from these chemical reactions we are going to get. If we are eating something, the breakdown of food will be there, energy will be released, chemical reaction, right bache? The waste will be excreted out from our body, chemical reactions are responsible for everything. So metabolism is important. Metabolism and living organisms, these two things are synonyms, right? So without any exception, metabolism is a property of the living organism. First point clear? First point clear. Now in this metabolism, obviously the compounds are there which are taking part in the reactions. So we have the metabolites there. What we have there? Metabolites, the intermediates formed during that chemical reactions, right? Intermediates that form during these chemical reactions. So the most exciting aspect of chemistry deals with isolating thousands of compounds, small, big, from living organism, obviously, and to determine their structure and to synthesize if possible, right? So they are saying that we have made one list of organic compounds. Okay, done, right bache? So here they are saying that we are calling these biomolecules as metabolites. So what are basically the metabolites? They are biomolecules, basically the intermediates of the chemical reactions in our body, right bache Shamshir? The intermediates of the chemical reactions in our body. So these are the metabolites. Clear? So we have two forms, primary and the secondary. Usually, right, we know that when we use the word primary, when we use the word secondary, primary, main, secondary, it is basically the second priority. So here in the primary metabolite, in the living body, these are the compounds which are playing a direct role in the growth and in the physiology of that living organism. Are you getting it? When you are saying primary metabolite, so you are talking about the compounds, about the chemical compounds which are directly play a role in our growth, in the physiology. And secondary metabolites, their function is not so clear, right? They are mainly for the human welfare. The compounds that we get from the plants, from the fungi, secondary metabolites, we are using it for our welfare. Are you getting it? We are using it for our welfare, and this is what explained in the NCERT, that in animal tissue we notices the presence of all such category of compounds, right? These are the primary metabolites. We'll show you the table as well, right? So when we analyze plant, fungi, microbial cells, we'll see thousands of compounds other than these primary metabolites which are secondary, like alkaloids, terpenoids, your lectins, your essential oils, your drugs. Okay, so here you can see this comparison. So primary metabolites, they form during the growth phase. Secondary metabolite, they are the one formed during the end or near the stationary phase of the growth. Now, like, let's say it is just like a kind of outcome, right? A kind of compound that will be for the human welfare. That is how you are, right? Okay, that is how, this is what you need to focus. Now, these primary metabolite directly involved in maintaining normal physiological process. Physiological means that internal functioning. right? The processes which are going on in our body. So primary metabolite, they are directly involved in maintaining it. Now when you are talking about the secondary metabolite, so they are not playing any role in growth and development. So indirectly they are playing the role, but directly they do not have any role. Done. And then they are essential, they are important for primary growth, the primary metabolites, and secondary one, their role in living organisms is not discovered yet. So examples are your amino acids, right? Your amino acids, your carbohydrates, your proteins, here the rubber, the drugs, the spices, scents, pigments, all of them. So you can say that we got these things from the plants, from the fungus, and we use it for our welfare. So these are the secondary metabolite, not directly involved in the growth and in the physiology. Clear, bache? Yes, bache. So this is the table from NCERT, another most important table. Okay, it is a most important table. You should not miss it. You will definitely get one question from this part. So confirmed, 4 marks are confirmed. Master this table. Okay, master this table. Done, bache? So see, primary metabolites have identifiable functions and play roles in the normal physiological process, right, bache? And secondary metabolite, they do not. Clear? They do not. Now see the example. So pigments mein carotenoids, anthocyanins are there. So bache, this anthocyanin is a water soluble pigment. It's a previous year question. Carotenoids is the it is soluble in organic solvent, but this anthocyanin is soluble in the water. It is soluble in the water. Then alkaloids, morphine, codeine. Do you know the role of morphine? Yes. Do you know what is the function of morphine? Do you know the function of morphine and codeine? Anyone? Morphine, it's very common. Bache, morphine is analgesic. It is having analgesic properties, means it is a pain reliever. It is used during surgeries as well. It's a pain reliever. And remember, human health and disease, right? We say that the acetylation of morphine will produce the heroin. Okay, it's a pain reliever, analgesic. So codeine is also having the same role. So that's your homework. You people will write it down in the comment section. Okay, who's going to do the homework? Who's going to do the homework? Codeine. The role of codeine. Morphine, I told you, pain reliever, used in surgeries and all, used for the preparation of various drugs. Okay, so I'll wait, Janan. I'll wait. Then comes the terpenoids again, like your camphor. I think you all know about the camphor. Camphor, in Hindi we used to call it as kapoor. So kapoor, that camphor obtained from the plants, it is also a terpenoid, right? So monoterpenes and the diterpenes. So basically these are just the chemicals, right? Bache, essential oil mein lemongrass oil is there. When it comes to the toxins, heparin and ricin, important it is, right? Then lectins, concanavalin A. Then drugs, vinblastine and curcumin. They are anti-cancerous drugs. You know what? They are anti-cancerous drugs. This vinblastine is obtained from your sadabahar. It is obtained from Vinca rosea, also known as Catharanthus rosea, right? Family Apocynaceae. You all have seen this. Okay, you all have seen this. Okay, so polymeric substances may you have the rubber, the gums, and the cellulose. And here, okay, do you know what is this lectin? Yes. This table is important, don't miss it. And you all have seen Vinca rosea, it's very common, periwinkle basically. It's periwinkle in English. It is sadabahar in Hindi. Hanji, what is lectin? What is the role of this lectin? Give it a try. Very common it is. Here we have the example of the lectin, na, concanavalin A. But what exactly is a lectin? So anyone from Avengers batch, we have discussed it there. Yes, any student from Avengers batch? Lectins. Seriously, Nithya? Seriously? Anything else? Lectins. Proteins, seriously? Anti-cancerous, noops. Okay, again, so you have 2 homeworks. First of all, you need to write down this the role of codeine, and another one is what is lectin. Okay. What is lectin? This is what you are going to mention in the comment section, right? It is not anti-cancerous. Okay, it is not anti-cancerous. Clear? So now we need to start what? We need to start the carbohydrates. Okay, now what will we start? We'll start the carbohydrates. So firstly we'll finish carbohydrates, then amino acid, proteins, then lipids, then nucleic acids. Like this will go. Okay. Okay, so later on after the class you just need to put it in the comment section. What you need to do? You just need to put it in the comment section. Done, bache? Done? So now let's talk about the carbohydrates, right? Let's talk about the carbohydrates. So what do you know about the carbohydrates? Yes. Thank you, Ravindra Mehra ji. Now please focus here. What do you understand by the carbohydrates? Anything that you know? Carbohydrates are sugar, okay, fair enough. Anything else? Yep, anything else? Energy giving source of food, okay, what else? Yes, what else? Contain carbon, hydrogen and oxygen, polysaccharides, okay, and sugars they are. Yes, biomacromolecules. Nah. Wait, bache, wait. Starch, it has monosaccharide, okay. Okay, anything else? Anything else related to carbohydrates? Whatever you know, just write it down. See, that's very simple. Carbohydrates. The first thing that you need to know is that they are the hydrates of carbon. What are they, bache? They are the hydrates of carbon. When you talk about these carbohydrates, if chemically I need to define it. Wait. So, they are the hydrates of carbon. First of all, what are they? They are the hydrates of carbon. Like if you will see here in the carbohydrates, you will see that the number of carbon and the number of water molecules, they are same. Hydrates of carbon, especially when you talk about the monosaccharides. So number of carbon and the number of water molecule, it's same. It is the hydrates of carbon. Now chemically, if I need to define it, first of all, let me define it chemically, then we'll come to that points, the source of energy, this and that. But first of all, chemically, what are these carbohydrates? Chemically, carbohydrates are polyhydroxy. But I was expecting a very good answer, literally, right? But the answer was not so good. So chemically, carbohydrates are polyhydroxyaldehydes and polyhydroxyketones, or the compounds which on hydrolysis yield such compounds. Okay, so chemically, what are carbohydrates? Hydrates of carbon, I told you why. So they are polyhydroxyaldehyde, polyhydroxyketone, or the compounds which on hydrolysis are going to yield such compounds like polyhydroxyaldehyde or ketone. Now the word is polyhydroxy. What is the word? Polyhydroxy. So polyhydroxyaldehyde, polyhydroxy means poly means many, hydroxy means OH groups. So there will be many OH group. And when you are saying aldehyde, aldehyde is also a functional group, isn't it? Aldehyde is also a functional group. So it is C double bond OH. Isn't it? It is C double bond OH. So basically in this carbohydrate also, in this aldehyde group, can you see the C double bond O? Can you see the C double bond O? So you know that whenever there is such group C double bond O, we used to call it as carbonyl. Carbonyl, isn't it? It is carbonyl, isn't it? So as I said, polyhydroxyaldehyde and polyhydroxyketone. So now ketone is also the another functional group. It is C double bond O, and this ketone is what, bache? It is a sub-terminal group. This is what you need to remember. This ketone is a sub-terminal group, and when you talk about the aldehyde, it's a terminal group. Now, what is the meaning of it? See, terminal means ends. Terminal means ends. What is the meaning of terminal? Terminal means ends. Like, I'll give you one example. I think you all know about it, glucose. Right? You all know about it, glucose. Whenever we talk about the carbohydrates, we know just one thing. See, I'll explain monosaccharides, oligosaccharides and polysaccharides. Right now, I'm telling you the basics of the carbohydrates. So don't be like, ma'am, it is not given in NCERT. Then why are we discussing it? It is important to understand carbohydrates like this. Then only you can master polysaccharides. And even it will help you out in the class 12th as well, right? So somewhere it is going to benefit you people. So just have a look. So glucose is your C6H12O6. Right, the source of energy, our mean respiratory substrate, it is C6H12O6. And I am assuming that you all have seen the ring forms of glucose as well. This is what I'm assuming. This is the glucose. This is the glucose, the ring form, and even in the straight chain. If you know about it, very good. If not, then please start mastering this particular chapter. This is your glucose. Okay, this is your glucose. So carbon number is what? Carbon number is 6, H12O6. So even in the ring form, even in the straight chain, but ring chain form is Howard projection. Whenever we say na ring form, we use this word Howard projection. And whenever we talk about the straight chain in the carbohydrates, we use the word Fisher's projection. What is it? It is the Fisher's projection. Okay, it is the Fisher's projection. Clear? Clear? So carbohydrates. Carbohydrates are polyhydroxyaldehyde, polyhydroxyketone. Poly means many, hydroxy means OH. And that is what you people can see here, that in the structure of this, in the structure of your carbohydrates, there are many OH groups. There are many OH group. So it can have aldehyde group, it can have ketone group. So when you are talking about the glucose, it is an aldose having aldehyde group, right? Having aldehyde group. Which group is there, bache? It is having aldehyde group, right? So this is the aldehyde group. So it is terminal. I told you, isn't it? Isn't it that this group is terminal, right? This group is terminal. So terminal means it is attached to the ends. Clear? Clear? So polyhydroxyaldehyde word clear. Now the next is polyhydroxyketone. Okay. Next is, yes, polyhydroxyketone. So you can take the example of your fructose. You all have, you all know about the fructose, isn't it? You all know about the fructose, isn't it? Again, carbon number is going to be same, isn't it? Here you will have this group. Fine. Here you will have this group. Rest all is same. So this group here is subterminal. So it is a ketone. So ultimately in aldehyde and in ketone, both of them are containing the C double bond O. That is your carbonyl group. That is your carbonyl group. Clear, bache? Clear? Any doubt? Any doubt? Done. So polyhydroxyketone and polyhydroxyaldehyde, clear that chemically this is the meaning of your carbohydrates. Yes, bache. Polyhydroxyaldehyde and the polyhydroxyketones, they are done. Polyhydroxyaldehyde and the polyhydroxyketones they are, and the compounds which on hydrolysis are going to yield this. Now when you talk about these carbohydrates, you will discuss about three things. Okay, you are going to talk about the three things. Okay, but they are monosaccharides, oligosaccharides, and then comes the polysaccharides. Okay, done. Then comes the polysaccharide. So when it is the monosaccharide, mono means single, mono means single, saccharide means sugar, saccharide means sugar, single sugar is there, saccharum word, saccharide word is attached to the sugar. Clear bache? Clear bache? So poly means many, poly means many, again saccharide means sugar. Okay, and when it is oligo, here you will see 2 to 10, 2 to 10 monosaccharides, 2 to 10 saccharides rather, not the monosaccharides, 2 to 10 saccharides rather. Clear bache? Clear? Right? So this is what we need to study. So ultimately hydrates of carbon, polyhydroxyaldehyde and ketone, or the compounds which on hydrolysis they are going to yield it. No doubt when we say the carbohydrates we use the word sugar, which is sweet in taste, right? Which is sweet in taste, but it is not mandatory that all the sugars are going to be sweet in taste. Your monosaccharides are sweet, even your disaccharides are sweet, but when you talk about the polysaccharides, no, they are tasteless. They are not at all sweet, they are tasteless. So there are different properties that you need to know. So first of all, we are going to start with what? We are going to start with the monosaccharides, right? How are we going to start? Now we are going to start with the monosaccharides first. So mono means single sugar, right? Single sugar. So these are the compounds which cannot further hydrolyze and they cannot further hydrolyze. Clear bache? The monosaccharides. Okay, so they are the simplest sugar. They are the simplest sugar which cannot further hydrolyze. Simplest sugar which cannot further hydrolyzed. Are you getting it? Yes. Are you getting it? Simple sugars which cannot be further hydrolyzed. So now when you talk about, and yes, they are sweet in taste. They are sweet in taste. And bache, I'll add one more word here. They are reducing sugars. We'll explain it later. They are reducing sugars. Right? I'm going to explain it, but later. Fine. So simplest sugar which cannot be further hydrolyzed, they are sweet in taste and they are the reducing sugars. They are sweet in taste and they are the reducing sugar. Now in the case of monosaccharides, there is a general formula. What will you see here in the case of monosaccharides? There is a general formula, that is CnH2nOn, or you can also write it like this, CnH2ON. CnH2ON or CnH2ON. Wait, let me write it. Done? Done? This is a general formula in the case of what? In the case of your monosaccharide. So now just look at it. The number of carbon here, the number of carbon here and the number of water molecules, it's same. The number of carbon and the number of water molecules, it's same. That is why we used to call it as hydrates of carbon. Okay, that is why they are the hydrates of carbon. I'll give you one example. Let's say your N is 6. N is 6. So this will become C6H12O6. Your glucose, yes or no? Your glucose, C6H12O6. Even the fructose is C6H12O6. Clear bache? Even the galactose is C6H12O6. So obviously this is the general formula when you talk about what? When you talk about the monosaccharide. So you can write it like this also, like this also. Clear bache? Clear bache? So monosaccharides, reducing in nature, sweet in taste, simplest sugar they are, main source of energy they are. You know that, right? They are going to give us the energy, the carbohydrates, right? 55 to 60% of the energy is obtained from the carbohydrates. Okay, okay. Because they will easily oxidize. They will give the energy. So done. So now in these monosaccharides, we need to discuss it in two ways. I told you, bache, that there will be the aldehyde group and there will be the ketone. There will be aldehyde and ketone. So basically there are two functional groups, yes or no? So if in the monosaccharides, the functional group is aldehyde, so you will use the word aldose, and if the functional is ketone, you will use the word ketose. Any monosaccharide having the aldehyde as functional group, that will come under this category, aldose, and if the functional group is a ketone, then it will come under the category ketose. This point clear? Yes or no? Tell me, is it clear? Yes or no? Aldose and ketose, aldose and ketose. Now, monosaccharides cannot be further hydrolyzed into other sugars, right? You cannot further hydrolyze them to other sugars. From monosaccharides, you cannot break them and you can get another sugar. This is what I'm trying to say. Like, let's say you are taking the example of a polysaccharides. You are breaking the polysaccharides. Obviously, you will get small subunits. That can be your simple sugars. That can be your monosaccharides. But when you are going to break the monosaccharides, you will not get the another sugars. But here, the number of carbon atoms can vary. Right, number of carbon atoms can vary. No doubt I told you the general formula here. I told you about the aldose and ketose here. But what else you need to remember? That see, if you talk about the number of carbon atoms in the case of monosaccharides, then the number of carbon atom is from 3 to 7. Right, it is from 3 to 7. Now, many times the students, they get confused here that, ma'am, if it is a monosaccharide, then how can you say that the number of carbon is from 3 to 7? Let's say there is one brick. Okay, that brick is 2 centimeter long, another brick 3 centimeter long, another brick 7 centimeter long, like this. So ultimately, what am I trying to say? All I'm trying to say is, okay, let's say you are constructing something. You are using the brick which is 2 centimeter long. It is very small, but I think you can understand. And you are constructing a doll house. So obviously, so you can use the different type of bricks. You can use the bricks having different dimensions as well. So it can be 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter. But ultimately, it is only one brick, right? It is only one brick. Let's say I'm telling you that so many bricks are placed. Let's say, imagine you, in front of you, you have so many bricks, you just need to pick one. You can pick any brick. It can have 2 centimeter, maybe it is of 2 centimeter, 3 centimeter, 4, whatever it is, whatever. Ultimately, you need to pick up only one brick. Same is the case here, monosaccharides, right? Mono means single, sugar is single, but it can be 2 centimeter long, 3 or 7, like this, but ultimately it's only one sugar. So let's say when it is 3 carbon containing compound, 1, 2, 3, like this. When it is 4 carbon containing, 1, 2, 3, 4, 1, 2, 3, 4 and 5. But ultimately it's a mono, it's a single unit, it's a monomer, it's a single unit, it's a single unit. So it is a single unit having 3 carbons. It's a single unit having 4 carbons. It's a single unit having 5 carbons. Fine? Fine? Got it? Got it? So, if the functional group is aldehyde, that monosaccharide will be aldose. If the functional group is ketone, that monosaccharide will be ketose, right? So, even the number of carbon can vary, but it will be in the range of 3 to 7. But right now, you have to go beyond NCERT if you want to understand this topic. So pay attention. It's important. Done? It's important. So that is about the aldose and the ketose. Okay. This is about the aldose and the ketose. Clear? Clear? Okay. So now the next point. Now see, if carbon number is 3, can I call it as triose? Like let's say N is equals to the carbon number. Okay, so if carbon number is 3, carbon number is 4, carbon number is 5, it's 6, it's 7. So if the carbon number is 3, it will be triose, tri-3. Carbon number 4, tetrose. Carbon number 5, pentose. Carbon number 6, it's hexose. Like your glucose is a hexose. And carbon number 7, it is going to be heptose. Are you getting it? It is going to be heptose. Clear, bache? Clear? So hexose, heptose. So if it is a triose, carbon number is 3. Tetrose, carbon number is 4. Pentose, carbon number is 5. Heptose, hexose, carbon number 6. Heptose, carbon number 7. So in a monosaccharide, in a monomer, you can see that carbon number can vary from 3 to 7. 3 to 7. Now, bache, let's say if the functional group is aldose and the ketose, obviously even it is also going to change something, no? Aldose and ketose. Aldose and ketose. So when it is aldose, functional group is aldehyde. Okay, functional group is aldehyde. So 1, 2, 3. It's very easy even. C double bond O, H. Here it will be CH2, OH. And here triose. Triose. 1, 2, 3. Again a triose, but it's a ketose. So obviously accordingly the nomenclature also varies. So when it is the triose and it is aldose, or it is a triose and it is a ketose, so this is your basically this is your glyceraldehyde, right? This is your glyceraldehyde. If phosphate will be attached, then it will become phosphoglyceraldehyde, right? Phosphoglyceraldehyde. So let me write it here. So this is glyceraldehyde, glyceraldehyde, and when it is a ketone, it is going to be dihydroxyacetone. Okay, it is dihydroxyacetone, right? Di means 2, hydroxyacetone it is. So they are the example of these trios. So I can write down the examples here, that this one is your glyceraldehyde and this one is your dihydroxyacetone. Yes or no? Dihydroxyacetone. Yes or no? Now, when it is a tetrose, 4 carbons are there, right? 4 carbons are there. So now, of course, bache, examples will vary. So in the aldose, we have the example of erythrose. We have the example of erythrose. And now, in the case of ketose, while naming it, you will add ul. You will add ul. What are you going to add? Leaving this triose, right? You will find it everywhere. You are going to add ul. Like here, if it is erythrose, in the case of ketose, if the functional group is ketone, it will be erythroulose. Ul will be added. Ul will be added here in ketose. Like for the pentose sugar is your ribose. Here in the ketose, you will add ribulose, ulose. So again, this ul is added here. When it is a glucose, here you have fructose, right? When it is the pseudoheptose, here you will have pseudoheptulose. Okay, so ultimately when it is a ketone group, so ul will be added here to the nomenclature. Clear, bache? Ul will be added here to the nomenclature. Done? No, other examples are also there. Like here in pentose, you can also see the example of xylose. Here you will see the example of xylulose, right? So other examples are also there. Are you getting it? Triose, tetrose, aldose, ketose. Sure. So I told you, bache, when it is in the straight chain, you will call it as Fischer projection. When there is the straight chain, you will call it as Fischer projection. And when it is in the ring form, you will use the word Haworth projection. Right? You will use the word Haworth projection. Clear, bache? So in the ring forms, you will see 2 rings. Okay, when it is cyclic. And let me tell you, bache, this monosaccharides in the aqueous solution, they are always in the cyclic form. Your glucose in the aqueous solution, it is in the cyclic form. Now I don't know that if there is a pH change of that compound, it can vary or not. That you can ask from HSP sir and Wasim sir. Okay, I don't know that depth, but ultimately when it is the cyclic form, it is the Haworth projection, and you will see 2 cyclic forms. Basically you will see 2 cyclic forms. One is your pyranose and another is your furanose. Right, one is your pyranose, another is your furanose. pyranose, Fure means 4. Like remember this, 4 carbon and 1 oxygen. This is what you can remember. 4 carbon, 1 oxygen. So if here it is having 4 carbon, so in the pyranose it is going to be 5 carbon, 1 oxygen. Like it will be there in the ring. Like see, I hope you all have seen this ring, right? I hope you all have seen this ring. And in furanose, it will be like this. Okay, it will be like this. Okay, sure. So this is pyranose. So see, 5 carbon atom, carbon 1, carbon 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. So in the ring, you will see 5 carbon and 1 oxygen, right? And here you will see 4 carbon, 1, 2, 3, 4. 4 carbon and 1 oxygen. Clear, bache? Yes, 4 carbon and 1 oxygen. So this ring form is the furanose and this ring form is the pyranose. Okay, so ultimately, see, this is my advice. Rest it's your wish. At least you should know the structure of glucose, the structure of galactose, the structure of fructose, the structure of ribose, deoxyribose. At least this is what you people should know from the monosaccharides, right? You should know about the structures. You should know how to draw these structures. So that's your homework. We will discuss it in class, but again, that's your homework, right? You need to learn the structure of these. Fine, glucose, galactose, fructose, ribose, deoxyribose. Okay, glucose, galactose, fructose, ribose, deoxyribose. Done, bache? Is that clear? Is that clear? So you know, there are 2 forms. You might have seen this in the case of glucose, here in the case of fructose also, in the case of ribose also. You might have seen it. Isn't it? Isn't it? So now, there are 2 terms that we will discuss and then we will enter in the disaccharides. See, one term is your anomers and another term is epimers. One term is anomers, another term is epimers. Do you know the meaning of anomers? Anyone? Do you know the meaning of anomers? Yes. I told you about the ring forms, isn't it? I told you about the ring form. I told you about the Fisher projection. And see, when it is the glucose, look at the structure, which is so easy. Okay, just look at the structure. It is so easy. It is in this ring form. This ring is pyranose, right? This is the Fisher projection. So glucose is an aldose. It is having the aldehyde as functional group. So it is a terminal group. You will attach it to the sides. Okay, so aldehyde is C double bond OH. Then you are left with what? You need to satisfy the valency only, HOH. And yes, always remember, on 3rd carbon, when you are drawing this glucose, when you are making the structure of this glucose, on 3rd carbon, the OH is towards this side, H is towards this side, rest all same. It's very easy. Now when you are making the ring also, right, I'm not going to explain you the condensation here. So O is given here. Now you see carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6, right? 1, 2, 3, 4, 5 and the 6 here and the 6 here. Clear? So 1, 2, 3 on 3rd carbon, because here even in the ring, even in the straight chain, you can see the 3rd carbon, the OH is towards this side. Yes, the OH is towards this side. So here OH is above. This is what you need to take care. This is your glucose structure and it's very easy. It's very easy. Clear, bache? It's very easy. Now I'm telling you about the anomers and the epimers. So first word is anomers. Now as I said that in the aqueous solution, your glucose is in the cyclic form. Anomers are very simple, bache, because here in the anomers, we will see the difference of that H and OH group to the carbon number 1. Like see, if it is like this, and to understand it, of course, you need to know the glucose structure first. So, bache, please do your homework properly, okay? Please do your homework properly. Done. So now when you look at it, ultimately you know that it is glucose. Ultimately you know that it is glucose. Now see, this is the alpha D glucose, or you can simply write it like alpha glucose, right? I will not explain you the D and the L, dextrorotatory, levorotatory, dextro towards the right side, levo towards the left side. And do you know when you write it, when you are writing capital D or capital L and the small d and small l, even it varies, but that will be again explained by your HSP sir when he'll start this chapter, right bache? So as of now, whatever is important for your biology, and even you know that extra, whatever extra is required, I'll tell you this. So this is the alpha glucose, this is the beta glucose. Now you must be thinking that, ma'am, what is the difference? You guys can see, right? When you look at the carbon number 1, when it is the alpha, from this alpha, this is what you need to remember, alpha means above. Alpha means above and beta means below. Alpha means above and the beta means below. So alpha above, like H is above, H is below. That is how you can remember it, isn't it? Isn't it? Isn't it? When it is the alpha glucose, it's like this, HNOH. And when it is the beta glucose, it's like this, hydrogen is below. Simple it is, isn't it? Isn't it? It's very simple. It's very simple. So these are the anomers. So in the case of anomers, you will see that the H and OH position will be changed at only one carbon, and that is what? That is your carbon number. That is your carbon number 1. That is your carbon number 1. So these are the anomers, right? These are the anomers. So the position of H and OH group is changed on carbon number 1 only, right? Position of H and OH will be changed on the carbon number 1 only. This is what the anomers is. Now the another word is epimers. See, epimers is not given in your syllabus, but I told you to remember the structure of galactose, right? So that is why I'm telling you. Even you'll find the word mannose again and again. So glucose, okay, mannose. It's not maltose, it's mannose, okay. And then comes the galactose. Fine, then comes the galactose. So you all know the structure of glucose, isn't it? You all know the structure of glucose, isn't it? This is the structure of glucose. This is the structure of glucose, yes or no? Isn't it? Yes or no? This is the structure of glucose. So now you know that in the glucose, at this third carbon, your OH will be like this. Here also at third carbon, your OH is going to be like this. On your third carbon, basically, your OH will be like this. Now when it is a mannose, if you look at the second carbon, on second carbon also, OH is towards this side and H will be here. And here, in the case of galactose, OH is like this. Rest everything is same, right? Just look at it very carefully. right? Just look at these three structures. Just look at these three structures. This one is glucose, this one is mannose, this one is galactose. Now, even when you talk about the glucose, galactose and the mannose, ultimately the function, the formula is same. It is C6H12O6. It is C6H12O6. Now, bache, when you see this mannose, you will see on the second carbon, the position of OH and H is changed when you compare it with the glucose. When you look at this galactose, you will see only at one carbon. It is mandatory only at one carbon, right? The position of OH and H is changed when you compare it with the glucose. So we say that mannose is the epimer of glucose at carbon number 2. Galactose is the epimer of glucose at carbon number 4. So whenever we use the word epimers, these are the compound, these are the isomers in which rest everything is same, but the group, the HOH position will be changed at only one particular carbon. Clear, bache? Only at one particular carbon, right? So these are the isomers which are formed as the result of interchange of H and OH position only at one carbon, right? Only at one carbon. Like when you compare it with glucose, rest everything is same as I said. Rest everything is same as I said, right? So, but here in mannose, here and in galactose at carbon number 4. So this position is fixed. Galactose it will be there at carbon number 4 only. And in the case of mannose, it will be there at the carbon number 2 only. Got it? Yes, everyone, got it? So let's say if I need to draw the structure of, if I need to draw the cyclic forms here, HOH, HOH, OHH, HOH, and here HCH2OH. This is your glucose. Now same way, draw the galactose. HOH, HOH, OHH. Because in galactose, on 4th carbon, right? On 4th carbon, the position of OH and H was changed. So it will be like this. It will be like this, right? It will be like this, yes or no? Tell me, yes or no? So that's it, that's all, bache. So this one is your glucose and this one is your galactose. This one is glucose, this one is your galactose. Clear? Okay? Bache, it's not same. Please focus here. So in the paper, they can ask you this question, right? They can give you the structures and they can ask you which one is glucose, which, acha, how is it same? Can't you just focus here? The 4th carbon and the change is at the position, 4th position only, no? The change was there on the 4th carbon, na? So obviously that is how you're going to draw it. H above, OH below, like this. And it is the 1st carbon, H is above, so it is the alpha glucose. Okay, it is the alpha glucose. Hanji, what is the issue there, bache? Tell me, what is the issue? Tell me what is the issue. And please be quick. Be quick. Any confusion, bache? So I think, I think alpha beta. Alpha beta. See, here we need to do this. That's all. So alpha beta mein you need to focus on the, in the anomers, in the alpha beta case, you need to focus on the 1st carbon only. You need to focus on the 1st carbon only. Bache, epimers, all 3, they are same. So, bache, they are going to be same. There will be the change in the position of only one H and OH group. This is what I'm saying. That is the definition of epimers. They are the isomers that are formed by the interchange, right? Interchange of H and OH group at a particular position. Okay, so here when it is the mannose, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, 1, 2, 3, 4, 5, 6. When you look at the glucose, right? OH is towards this side, left side, and here H. But here in the mannose, rest everything is like glucose. But at the 2nd carbon, on 2nd carbon, H and OH is changed, na? So what's the confusion here? What is the confusion here? Rest it is also like glucose, it is also like glucose, but they are epimers. So what is the meaning of epimers? That only on one carbon the H and OH will be interchanged. So in the case of mannose at second carbon, in the case of galactose at fourth carbon. So what's the confusion here? Tell me, what is the confusion here? So see, the structure of galactose is also very easy, isn't it? The structure of galactose is also very easy. Now, when you talk about the ribose, ribose is a pentose. What is a ribose? Ribose is a pentose or hexose? What is a ribose? Pentose or hexose? Hanji, but just watch the lecture again, you'll get the clarity. What is a pentose? Write down the formula of ribose then. Ribose is a pentose, na? Write down the formula of ribose then. Write down the formula of ribose. Formula. Ribose is a pentose, you are right. Ribose is a pentose, you are right. But what about the formula? See, it's very easy. CnH2nOn. So the carbon number is 5. So it's going to be 5 into 2, 10. Isn't it? That's the formula of ribose. So it's very easy. So you know the CnH2O. It is N na? So why are you mentioning 6? It's 5 only. Okay, that is the ribose. So in the case of ribose, if you know that we will have the furanose, right? The ring form is furanose, isn't it? The ring form is what? It is furanose. Yes or no? Yes or no? The ring form is what? It is the furanose. It is the furanose. So you need to arrange that in this ring, right? In this ring. That's your homework, you will draw it. And moreover, do you know about deoxyribose? Deoxyribose, which is there in the DNA. You know that ribose is a sugar. It is a part of RNA. RNA is the ribonucleic acid. It is a genetic material and obviously playing other role in our body also. And when you are talking about the deoxyribose, right? In the case of deoxyribose, you know it. D means without oxygen. Like here, when you compare the ribose and the deoxyribose, you will see the one oxygen is missing, and it is missing at carbon 2. Okay. So obviously, then the formula of this deoxyribose will be C5H10O4. C5H10O4. Am I right? It will be C5H10O4. Am I right? Yes. C5H10O4. Am I right? So it is an exception. So deoxyribose is a monosaccharide, or you can say that it is a carbohydrate which doesn't follow the general formula. It's a carbohydrate which is an exception. It doesn't follow the general formula. Okay. It doesn't follow the general formula, but still it's a carbohydrate. Fine. So you can see the structure also. See, this is what I have added for all of you. Triose, tetrose, pentose, hexose, heptose. 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon. Glyceraldehyde, erythrose, ribose and deoxyribose, glucose, fructose, pseudoheptylose. These are the examples. So now I think you guys can differentiate. Like we discussed ribose in RNA. And when you talk about the ribosco, right? Ribosco. Ribulose bisphosphate. What is it? It is ribulose bisphosphate. And a ribulose, ul is there, right? Ul is there. Now see the different structures here. Okay, this is the glyceraldehyde. Okay. So see here, when I was drawing the structure, when I was drawing it, even I was noticing it at that time, but I didn't point out. Like see, OH is mentioned here, so we should take the OH here. Like this is not the, it is not mandatory, and this is what you are going to ask the HSP sir. Fine. It is, you are going to ask the HSP sir that is it mandatory that if we are writing OH on this side, so we should write C double bond O on this side, or we can write it anywhere. As per my knowledge, we can write it in any way. But again, ask HSP sir. For sure, he will give you one reason, and you have to tell me that reason. Fine. Will you do it? Yes. Tell me, will you do it? Like, this is what I have observed now. So basically, the reason can be the structural symmetry or something. But you are going to ask it from HSP sir, and he'll tell you the proper reason, and you will tell it to me. Fine. So now when it is the erythrose, 4 carbon. See, pentose, that is your ribose, 5 carbon. Fructose, 6 carbon, but it is the ketose subterminal functional group, and it is the glucose, aldose, hexose, aldose. Any doubt? Doubt? Yes, bache. Any doubt? See, aldose, ketose clear. Aldose, ketose clear. So see the alpha D glucose here, alpha D glucose here, right? And that one is the beta. So always remember this trick. Alpha means above. Your hydrogen is above. Okay, and you have to check the first carbon only. You have to check the first carbon only. Done, bache? Sure? Sure? So this is the deoxyribose and ribose. So you can see here OH, H, HOH, HOH, and CH2OH. This is the 5th carbon. So when you compare ribose and deoxyribose, you need to remember the structure, right? So in the deoxyribose sugar, on 2nd carbon, oxygen is missing. Always remember it should be the 2nd carbon only, right? On 2nd carbon, oxygen is missing. So it is deoxyribose, the part of DNA, the genetic material. And that RNA, ribose is the part of RNA. Done, bache? Okay. So now we need to start what? We need to start the oligosaccharides. Right? Next topic is what? Next topic is your oligosaccharides. Fine. Fine, so we'll start it after a break. Now you people will get a break for 15 minutes. Okay, we'll start at 7. Basically, it's a tea break. Hai na? So I am a tea addict. I need my tea desperately. Fine, so then we'll resume. Okay, happy? Then we'll resume. Hi kids, even I'm back. So how was your not tree break, but tea break? How was your tea break? Now I'm audible, na? We are back with the energy. That's a good thing, Srinath. But in your case, this is what I'm observing. You come here, you just chit chat and you waste your time. And trust me, for that you don't need energy. 10 cups. No, just 3 cups, yaar. Mostly 2 cups, rarely 3 cups. है ना? Chalo. So let's interact for a minute and then, okay. So tell me after this class, which chapter you want me to start? Which chapter you want me to start? Tell me, which chapter you want me to start? Wasim sir is a liar. 10 cups a day. And I told you, in the Bangalore, they used to give the tea in such a small cup. So see, my cup, although it's not completely filled, it is up to this mark. So, the Bangalore's 3 cups is equivalent to my 1 cup. So obviously you can then compare. है ना? अच्छा, structural organization. Seriously, structural organization. Okay, we'll think of it. How many of you want me to start this chapter, structural organization? Genetics, okay. What else? Plant physiology. अच्छा, और कुछ? Anything else? Genetics. Shri Harsha, why is it important? It is not going to come in the NEET examination. Human physiology, okay? Okay, you can put your suggestions in the comment section. And yes, today I'm going to, hopefully till then I'll finish my class. Today I'm going to, yes, I'm going to provide you a strategy. This session is going to be very important for all of you. So first of all, just go to this video and hit the like button. Quick, just go to this video and hit the like button first, right? Only 6 likes are there. Everyone just hit the like button right now. Make it 60. Fine, make it 60. So this session is going to be very important for you, right? You will realize that actually we just have 288 days for the NEET examination. Right, the detailed strategy I have provided you here, and even the timetable, the routine that you people should follow, even if you are taking coaching offline or online, whatever it is. So go and just hit the like button here, click the notify me there like this. Okay, so at 8:30 this video will be premiered and it is going to be very useful for you. It's still 6, just make it 60 right now. Shaurya, counseling has started. Quick, everyone. Quick, speed up. Still 11. Go, fast. Right, then I'm going to continue. I'm going to start the oligosaccharides. And what happened to me? Quick, then I'm going to start the oligosaccharides. Hit the like button. Just go to the video section of the channel, and then what you have to do, you just need to hit the like button here. So don't waste your time, don't waste my time, just hit it quickly so that we can continue with the oligosaccharides. And oligosaccharides mein disaccharides are very important for your syllabus. Okay, disaccharides are very important for your syllabus. So I'll check it after 10 minutes. It should be 60. Okay, it should be 60. Done. And yes, now your test series is at a price of 999. Okay, and in 999 rupees, you people will get 22 to 23 tests with the detailed test discussion sessions. Okay, so join it as soon as possible. Okay, join it as soon as possible. Done, bache? Okay, so now when you talk about the oligosaccharides, you are done with the monosaccharides. Now when we talk about the oligosaccharides, their general formula is, the general formula here is CnH2n n-1. Okay, in the case of oligosaccharides, what is the general formula? It's CnH2o n-1. CnH2n n-1. Now here in the oligosaccharides we have monosaccharides, obviously, right? What do you have here? You have monosaccharides from 2 to 10. So 2 to 10 monosaccharides, 2 to 10 monosaccharides, when they join, they are forming the oligosaccharide. Let me explain it in a better way. Okay, let me explain it in a better way. So in the oligosaccharides, you have disaccharides, you have trisaccharides, tetrasaccharides are there, pentasaccharides are there, hexa, hepta, like this. So basically in the oligosaccharides, now you don't have the monomers, you don't have the monosaccharides. Now that monosaccharides are going to join. Let's say your glucose is a monosaccharide. Now glucose will be like, I cannot live alone, I need a partner. So glucose will join. Let's say glucose will join with another glucose. So now how many sugars are there? How many sugars are there? 2 sugars are there. So can I say that it's a disaccharide? Of course I can. Right? Can I say that it's a disaccharide? Of course I can. Isn't it? Isn't it? Yes or no? So disaccharide, 2 monosaccharides are joined together. Trisaccharide, 3 monosaccharides are joined together. Tetrasaccharide, 4 monosaccharides are joined together. Same way, penta, hexa, hepta, like this. Okay, like this. So in the case of oligosaccharides, as I said, the general formula is CnH2n n-1, right? So here you will see that the monosaccharides ranges from 2 to 10. So if 2 monosaccharides are joined together, it will be disaccharide. If 3 monosaccharides are joined together, tri, tetra, like this. Now you got it. What is the meaning of oligosaccharide? Yes, everyone. You got it right? That what is the meaning of oligosaccharide? Sure? Sure? Could you say what exactly it's from 5 to 10? Obviously, it's simple. Pentasaccharides, hexasaccharides, like this. Simple, it is related with the chemistry. Okay, related with the chemistry. Fine. So, di, tri, tetra, like this. Now, in our syllabus, we need to focus on the disaccharides. Okay. So, in the disaccharides, we have the examples of lactose, maltose, sucrose. Even isomaltose is also there. These are the 3 important examples that you people need to remember. Okay, these are the 3 important examples that you need to remember. So we are not going to focus on tri, tetra, hexa, hepta like this. We are going to focus on the disaccharides only, right, bache? So we started with monosaccharides, then we moved to oligosaccharides. Oligosaccharides are having general formula CnH2n n-1. In the oligosaccharides, right, the monosaccharide number can range from 2 to 10. So if 2 sugars are there, it is going to be disaccharides. Any doubt? It is going to be disaccharide. Any doubt? Clear, bache? Now, before proceeding, even I'll tell you one more thing. Here I was teaching you about the glucose, galactose, and the fructose, no? Right? So, you know, glucose is also known as the brain sugar. First of all, let's discuss it. Then I'll go ahead. Glucose is your brain sugar. Not the brain sugar, the blood sugar rather. My bad. Glucose is basically your blood sugar. You know now, glucose is the main respiratory substrate, right? Ultimately, this glucose will be oxidized and we are going to get the energy. We are going to get the energy, isn't it? Glucose, it is the blood sugar. It is the blood sugar. And you know that when there is the excess of glucose in our blood, so our liver will convert that glucose into glycogen. Our liver will convert that glucose into glycogen. We will discuss it in today's class, right? Which is glucose. And now when you talk about the galactose, can you tell me something about the galactose? Yes. Can you tell me something about the galactose? Right? Do you know it is the galactose which is the brain sugar? Do you know that? I thought I should share this information with you all. It is the galactose which is the brain sugar, right? Right. It is the brain sugar. Many times when we ask the students which one is the brain sugar, they used to say glucose. No, it's galactose. It's galactose. Your galactose is abundant in the nervous tissue. When you see the nervous tissue, the brain, in the entire nervous tissue, the galactose is too much. But it is not for the energy there. It is not in the free form. It is associated with the lactose there. But the quantity of this galactose is too much. Clear, bache? The quantity of this galactose is too much. So it is the most abundant sugar in brain and in the nervous tissue. Okay? It is the most abundant sugar in brain and nervous tissue. So it is not present in free form, but is associated with the lactose. Okay, it is never occurring in free form. It is basically a component of your lactose. Clear, bache? Clear, bache? Done? Sure. So it is a component of your lactose. Fine. It is the component of your lactose, galactose. Now when you talk about the fructose, you know now fructose is the fruit sugar. Yes. Do you know that fructose is the fruit sugar? Fructose is also considered as the artificial sweetener. Right? It is the fruit sugar. In the fruits, this sugar you are going to get the fructose. But again, here we have one exception. The exception is your grapes. In the case of grapes, the sugar is not fructose. Grape is a fruit, no, but the sugar is glucose. Okay, but the sugar is glucose. Done? Done? So fructose is the fruit sugar. It is also the sweetener, right? It's the natural sweetener, not the artificial. It's the natural sweetener. Fructose, having good, high glycemic index. So fructose, fruit sugar it is, but in your grapes, the fructose is not present. It is going to be the glucose, right, bache? So we were talking about the oligosaccharide, and where we are going to talk about the disaccharide. So I have given you 3 examples: lactose, maltose and sucrose, which we need to discuss, which we need to revise. But before that, don't you think that if we are talking about the disaccharides, means we are going to join 2 sugars together, right? We are going to join 2 sugars together. So there should be a bond in between, isn't it? So in the case of carbohydrate, the bond which is going to join the sugar is the glycosidic bond. Which bond is there? It is the glycosidic bond. Yes, bacho, which bond is there? It is the glycosidic bond. And this glycosidic bond is formed by the dehydration. So dehydration is going to occur here, means minus H2O will be there for the bond formation. What is going to happen here, bache? There will be the water release. So dehydration is going to take place. Okay, it is a dehydration which will occur. Fine, glycosidic bond will be there. So like I'll take you, let's take one example. Take the example of glucose. Okay, just take the example of glucose. Now I think you know the structure of glucose, isn't it? It's very easy to remember the structure of glucose, isn't it? Yes or no? Isn't it? So here you have H, you have OH. Here you have H, you have OH. So Jasween, take the example of 2 glucose molecule. I'm not specifying any alpha, beta now. I'm just giving you this example generally. Okay, because we need to understand the glycosidic bond formation here. What we need to understand? We need to understand the glycosidic bond formation here. So can you see the 2 glucose molecules here? 2 glucose monomers here? Yes, bache. Can you see the 2 glucose monomers here? Now I need to join them together. Then only they will be, right? Right? Then only they will be the disaccharide. Now what are you going to do? You're going to release the water from this side. Like let's say from this part, there will be the minus H2O. The dehydration is going to occur. The dehydration is going to occur. Clear, bache? What is going to take place here? The dehydration is going to occur. So after that dehydration, what will be the scenario? Let me tell you this thing first. Just look at it, bache. This is the glycosidic bond formation, and always remember, in the case of carbohydrates, right, in the case of these disaccharides or in polysaccharides, you people are going to see this bond formation. That is your glycosidic bond formation. right bache? That is your glycosidic bond formation. So here just know H will be there, H will be there. So it is H2O, 2H out, 1 oxygen out. So only 1 oxygen is left. So there will be something like this. There will be something like this. Like in between two glucose, you guys can see the structure is going to, yes, bacho, the structure will be like this, yes or no? Yes or no? Right, this is the glycosidic bond. Here you people can see the glycosidic bond. So it is formed by the dehydration, Jasween. It is formed by the dehydration. Clear? Now in the books it is also written. Now, yes, when two glucose molecules they join, right? When two glucose molecules they join together, then they form a disaccharide, and we call that disaccharide as maltose. Right? Maltose, which is the malt sugar, the sugar present in germinating seed. Right? It is the malt sugar. It is the sugar present in germinating seed. Which sugar it is? Malt sugar. Right? So two glucose together, they are forming what? They are forming the maltose. They are forming what? They are forming the maltose. So you might have heard this, that alpha 1,4 glycosidic bond. Right? You might have read it. Alpha 1,4 glycosidic bond. Isn't it? Alpha 1,4. Even leave alpha. Right? Chalo, theek hai. Let's consider alpha. So alpha, it is the alpha glucose. Isn't it? It is the alpha glucose. H above, OH down. Okay. Now 1,4. When you look at this glucose, so this is the carbon number 1 here, carbon number 2, carbon number 3, 4, 5 and 6. Here also 1, 2, 3, 4, 5 and 6. So bache, bond formation. The bond formation is in between the first carbon and the fourth carbon. Right? Why do we write it like this? Alpha 1,4. Because the bond formation is in between the first carbon and the fourth carbon. The first carbon and the fourth carbon. Are you getting it? So that is why it is alpha 1,4 glycosidic bond. It is alpha 1,4 glycosidic bond. We are even going to talk about 1,2 glycosidic bond, even 1,6 glycosidic bond. So basically it is showing us the carbon number. First carbon or from one monosaccharide, second carbon from another. First carbon from one monosaccharide, sixth carbon from another. They are involved in bond formation. This is the meaning of this 1,4 glycosidic linkage. Any doubt? Any doubt? So this is the example of a disaccharide. This is the example of your, yes, this is the example of your, yes, mera bacha, maltose. So here you people can see the one glucose and the another, they are joining together. Isn't it? Isn't it? So this is the first carbon, this is the fourth carbon. So when there is the, when water will be released, when there is the dehydration. So dehydration means release of water, means condensation of these two sugars together. So this is your glycosidic bond, and here you guys can see the maltose. Any doubt? Any doubt? And obviously if there will be the hydrolysis, breakdown of water, breakdown in the presence of water, if water is released basically, if it is minus H2O, then obviously these two glucose will get separated. So this is the malt sugar. Any doubt? This is the malt sugar. Okay, so it is even the intermediate compound in the starch digestion. Okay, it is the intermediate compound in starch digestion. Clear? Fine, in the starch digestion. Clear? So next, here we have maltose. Clear? What do we have here? Here we have the maltose. So obviously we have discussed it. So alpha D and beta. Now this is the lactose. But lactose is the milk sugar. Even it is important. And it is given in your human physiology. So it is important. So lactose is your milk sugar. What is it? It is milk sugar. So definitely it is absent in your plants. Isn't it? It is absent in your plant. It is the milk sugar, lactose. So in the case of lactose, lactose is made up of your glucose plus galactose. Lactose is made up of what? It is also a disaccharide. It is made up of your glucose and galactose. Glucose and galactose. But can you see the bond here? Like here we are drawing it like this. Okay, the carbon number 1 and 4. But here, can you see this? This bond is 1,4. 1,4 is there, but its shape is little different. Its shape is little different. Why? Because it is beta 1,4. It is beta 1,4 glycosidic bond. Right? It is beta 1,4 glycosidic bond. Let me explain this part to you. So lactose made up of glucose plus galactose. Made up of glucose plus galactose. Right? Made up of what, bache? It is made up of your glucose plus galactose. So it is beta 1,4 linkage between glucose and galactose. So it is the milk sugar, the least sweet sugar it is. Now, okay, I was showing you this thing here. Okay, just look at the diagram. Just look at the diagram. OH was here, H was down. Just look at the fourth carbon. Right? This one is first, this one is second, this one is third, this one is fourth, this one is fifth, this one is sixth. Here also first, second, third, fourth, fifth and sixth. Right? First, second, fourth, fifth and sixth. Guys, just look at it very carefully. I told you about the galactose structure. I told you galactose is the epimer of glucose. Rest everything is same in the galactose and glucose structure. Only at the fourth position, on the fourth carbon, basically, the OH and H position will be interchanged. The OH and H position will be interchanged. Here you will see, like this is the glucose where OH is down. Here it is above. So that is the difference in their structure. Yes or no? That is the difference in their structure. Yes or no? Let me draw it here. So it's beta. Ultimately it's beta. So if it is beta, OHH, HOH, OHH, this is galactose, isn't it? It is galactose. It is not glucose, bache. Always, bache, please pay attention here. You can make mistake in the NEET examination. It is your glucose. It is your galactose and it is your beta galactose. It is your beta galactose. Why beta? Because here on first carbon H is below, OH is above. Now see, in the glucose also we mentioned this OHH like this, but here because OH is above, H is down. So this is showing that it is a galactose. It is galactose. I hope you are getting my point. Yes. I hope you are able to understand it. Right, now draw the glucose here. Draw the beta glucose here. H, OH, H, OH, OH, H, H, OH, H, CH2OH. So now can you differentiate? This one is your galactose. This one is your beta glucose. Okay, beta glucose. So 1, 2, 3, 4, 5. And the sixth, and here 1, 2, 3, 4, 5 and the sixth. Clear? Clear? Isn't it? Right? So now obviously again here the chemical reaction will be there. The dehydration should be there. Yes or no? Hanji, minus H2O should be there, na? Dehydration should be there. So obviously when the dehydration occur, so what is going to happen here? H2O. So the bond will be like this. Yes. So it is showing beta 1,4 linkage in your lactose. Clear? It is showing beta 1,4 linkage in your lactose. So lactose plus glucose. Clear, bache? Galactose plus glucose. And same way you have the sucrose. And now this sucrose, it's very interesting. I'll tell you about the properties here. Here you will see glucose plus fructose. What will you see here? Glucose plus fructose. Bache, this is what you need to remember. What do we have in the case of sucrose? It is the glucose plus fructose. Yes, bache, it is the glucose plus fructose. Now, see this. This is the sucrose. Okay, this is the sucrose here. So, glucose, HOH, HOH, OH. Any doubt? Any doubt in glucose structure? Do you have any doubt here in glucose structure? I hope there is no doubt. And now, fructose. So, when you talk about this fructose, see, it's a... Yes, bache, when you talk about this fructose, what is it? It's a furanose. It's a furanose. Yes or no? It's a furanose. like see, this is, if let's say if this is the first carbon, so here you will see CH2OH and here you will see OH. Yep. So here you will see HOH. This is first carbon, this is second, this one is third, so third pe it will be like this, and when it is fourth, so CH2OH H. Done, bache? Fourth carbon and the right, see, first, second, third, fourth, sorry, this is the fourth carbon, not the third one, the fifth and the sixth. Clear, bache? First, second, third, fourth, fifth, and this one is the sixth carbon. So this is your fructose. So obviously now here in the case of this, right, glucose will give its first carbon, but fructose, the second carbon of the fructose, will be involved in the bond formation. So it's 1,2 glycosidic bond, right? It's 1,2 glycosidic bond. So this 1, 2, 1, 4, 1, 6 is just showing the carbon number. Okay, it is just showing the carbon number. So it's a furanose. It's a furanose, your glucose, sorry, your fructose, right? So that is how they are going to join. Is that clear? That is how they are going to join. Clear, bache? Sure? Yes? Sure? So now for the quick revision, let's have a quick revision. So we are talking about the disaccharides, hai na? So how will they form? By the condensation. And how will it occurs? By dehydration. So basically, which bond will be there? The glycosidic bond. Which bond is going to be there? Glycosidic bond. So you have, yes, you have maltose, you have lactose. It's very easy even. You have sucrose, isn't it? You have sucrose, isn't it? So when it is the, see, glucose is common everywhere. Glucose, glucose, and glucose, isn't it? So add. When it is maltose, it will be glucose. Now it is lactose. L is here. L is here. So that L is reminding galactose. In the galactose, we have the lactose now. That is how I remember. Galactose, may we have this lactose now. So galactose, the part of lactose. And this sucrose is having the fructose. Clear, bache? The sucrose is having the fructose. Clear, bache? Yes. Any doubt? Any doubt? Now when you are talking about the disaccharides, even you will see that these sugars are reducing sugars. Okay, I didn't explain you this now. That what is the reducing sugar and which one is the non-reducing. Let me explain this. And when you talk about the sucrose, sucrose is going to be non-reducing sugar. It is going to be non-reducing sugar. So they all are reducing, but again here the exception is your sucrose. And in the case of monosaccharides, all sugars are the reducing sugar. In the case of monosaccharides, bache Shri Harsha, all sugars are the reducing sugars. Let me explain this. That what is the meaning of reducing sugar? Bache, when you are saying reducing sugar na, it is having the property that it can reduce your Cu2 plus ions, that is your cupric ion, to cuprous ion. It's Cu2 plus na or Cu3 plus? Tell me. So cupric will be reduced to the cuprous. Cupric will be reduced to the cuprous. Am I right? Cu2 plus is cupric. Hanji, Cu2 plus is cupric. Yes or no? Quick. Guys, speed up. Cu2 plus is cupric, yes or no? है ना? So Cu2 plus will form Cu plus, cupric will form cuprous. So the sugars which can reduce cupric to cuprous ion, they are the reducing sugar. Why? Like, why are they doing it? Because they have free aldehyde and ketone group. Because they contain free aldehyde and ketone group. Free aldehyde and ketone group. So this free aldehyde and ketone group can react here. It can reduce this cuprous to, it can reduce this cupric to cuprous. Clear, bache? It can reduce this cupric to cuprous. These are the reducing sugars. And where do we use it? Do you remember chemistry में Benedict solution? Yes, Benedict solution. I think it is also having silver nitrate or something. I don't remember exactly. I literally don't remember exactly. So basically, you know, bache, we in the chemistry also, na, in the chemistry lab also, like say, let's say you have a mixture, you need to figure out that that mixture is containing your reducing sugars or not. So when you talk about the reducing sugars, you could talk about the monosaccharides, right? And even your disaccharides are also reducing, but sucrose is a non-reducing sugar. So how are you going to check it? You are going to put the Benedict solution there. So if your Benedict solution, right, if the color changing is there, basically your cupric will be reduced to the cuprous. So it is showing that yes, there is the presence of monosaccharides, there is the presence of reducing sugar. So this test is very important. So that is how we can use this property. So it is also for the identification. And moreover, you know that if in the urine, है ना, right, urine test, right, and the urine test is also there in the lab, like blood test, urine test is also there. So you know that the presence of glucose in urea is not normal. The presence of glucose in urine is not normal. The presence of glucose in urine is not normal because it is indicating the diabetes, it is indicating glycosuria, right? It is indicating diabetes mellitus. Right, and the presence of glucose in urine is glycosuria. So you know how do we check it? We check it with the help of this Benedict solution. Okay, we check it with the help of this Benedict solution. Clear bache? Clear bache? So this Benedict test, Fehling test, so they are used to detect the presence of, right, this Benedict test, this Fehling test, they are used to check the presence of glucose in the urine. Are you getting my point? Yes. Are you getting my point? Clear? Clear. So this is about the reducing sugar. So as I said, even your monosaccharides, even this maltose and lactose, they are reducing. But this sucrose is a non-reducing sugar. And this sucrose, bache, this sucrose is also known as invert sugar. Invert sugar. It is also known as commercial sugar. It is also known as table sugar. It is also known as cane sugar. And do you know why do we call it as a invert sugar? Because it rotates the plane polarized light. This disaccharide, and when it is in the form of glucose and fructose, it can rotate the plane polarized light. So this will be explained in your class 12 biomolecule chapter. So the enzyme invertase, right? So the enzyme invertase can break the sucrose into glucose plus fructose, which is a non-reducing sugar, invert sugar, table sugar, cane sugar, commercial sugar it is. Right? And even let me tell you, bache, plants after photosynthesis, plants in their phloem, right, they are not transporting the glucose, they are transporting the sucrose. Why? Because it is non-reducing. Okay, in the phloem also, it is the sucrose which will be transported. Okay, it is the sucrose which will be transported. Clear bache? Clear bache? Done? So in plants, the transport of sugar mainly occurs in the form of sucrose, the invert sugar, the commercial sugar, the cane sugar. So 1,2 glycosidic linkage is there, 1,4 but the beta 1,4 and alpha 1,4. Right? Any doubt? Any doubt? And yes, bache, when you talk about this fructose now, as I said, it is a fruit sugar. So you know that it is even present in the semen. Right, it is going to provide energy to sperms. Sperms are going to use the fructose as the source of energy. Remember, sperms are going to use the fructose as the source of energy. Clear, bache? So I hope it is clear. Any other doubt? Yep. Any other doubt? Done, bache? Sure? Clear? Any doubt? Any doubt? Okay. So this is all about the disaccharides that you need to know. So the next is, yes, next is polysaccharide. Okay. The next that we are going to discuss is polysaccharide. Clear? So any doubt? Yes. If there is any doubt, bache, you are allowed to ask. Then I'll start the next part, that is your polysaccharides. And that's very interesting. Yes, bache. Okay. Sure. No doubt. Seriously. Okay. So it's very easy. Poly means many, isn't it? Poly means many. Saccharides means sugar. So here you will see there will be many monomers together that are going to form the polysaccharide. So obviously above 10, right? It should be above 10. And you know that when you are talking about the polysaccharides, they are present in the acid insoluble fraction, isn't it, bache? When you talk about these polysaccharides, they are the part of acid insoluble fraction. They are the macromolecules because their molecular weight is above, right? Their molecular weight is above 10,000 Dalton, right, bache? Narayana is asking in sucrose alpha or beta. Actually, in sucrose, your glucose is alpha glucose, but your fructose is beta fructose. So that's the point there. Okay, Narayana. So polysaccharide, many sugars are there. So it should be above. The monomer number should be above 10. The monomer number should be, the monosaccharide number should be above 10. This is the case in the case of this. This is what we need to know in this polysaccharide. Right, bache? So now when you talk about these polysaccharides, right? So they all are non-reducing sugars. They all are non-reducing sugars, bache. And they are not sweet in taste. They are tasteless. Fine. They are not sweet in taste. They are tasteless. So it's not mandatory that all the carbohydrates are going to be sweet in taste. So they are not sweet. They are tasteless basically, right? They are tasteless and they all are what? They all are non-reducing. They all are what? They all are non-reducing. But bache, in the NCERT, there is one line which can be asked as a question. Okay, in the NCERT, one line is given which can be asked as a question. No doubt overall, you are saying that this is the property of the non-saccharides, that they are non-reducing, means they cannot reduce that cupric to the cuprous. Okay, now when you talk about the polysaccharides, because they are going to be the polymers, they are going to be the polymers. So they are quite, you know, they are their molecular weight is more. Okay, so in the case of polysaccharide, you will consider two ends. What are you going to consider, bache? Yes, what are you going to consider? You will consider the two ends. This is left end and the right end. Left end and the right end, isn't it? Isn't it? Left end and the right end. Yes or no? Yes or no? Tell me. Tell me. Left end and the right end will be there. Yes or no? Quick. So here, although they are non-reducing, but if you talk about their individual ends, like their left end and the right end, let's say if there is a chain, okay, if there is a chain, one side is your left side, another side is your right side, right? One side is your left side, another side is your right side. Let's say this one is your left side, this one is your right side. So when you talk about the left side, R for right, R for reducing. This is what you need to remember. R for right, R for reducing, because this side will be having that free aldehyde group or ketone group. So left side is going to be non-reducing. Left side is going to be non-reducing. So in the chain, this is what you need to remember. It is given in NCERT. Clear, bache? Clear, bache? It is given in NCERT. So in polysaccharide chains, the right end is the reducing end, left end is the non-reducing end. Okay, the right end is the reducing end, the left end is the non-reducing end. So this is the non-reducing sugar, the tasteless. It is polysaccharides, not soluble, right, in optically active solution. So That I'm not going to explain, of course. Okay, so any doubt here? Yes, everyone, any doubt here? Quick, do you have any doubt? So now when you talk about the polysaccharides, here also you will see one suffix. Suffix you know now, which will be used at the end, and that suffix is glycans. Glycans. Like let's say if hexose sugars, right, are making polysaccharides. Let's say if hexose sugars are making polysaccharide, because here the suffix is ANS, glycans. So if hexose sugars are making the polysaccharide, so it is going to be hexanes. ANS will be applied at the end. So this ANS at the end is indicating that it is a polysaccharide, right? It is a polysaccharide. I'll relate it with the cell chapter. In the cell chapter, when you talk about the algae, do you remember we talk about the algae, that when in the case of algae cell wall, right, it is having galactins and mannans. It is having galactins and mannans. Anyone in the class? Remember, algae is having galactins and mannans. Remember, galactins and mannans. It is not the bacterial cell wall, it is in the algae. So mannans, it's a polysaccharide. Galactan, it's a polysaccharide. Like mannan is the polysaccharide of mannose. So many mannose together are making this mannan, right? Right. So many glucose together are making this galactan. So that is how you people can relate. Okay. That is how you people can relate. Done, bache? So it's hexose. Clear? So polysaccharides insoluble in water do not taste sweet. They are tasteless. Clear? They are what? They are tasteless. Done? Done? We are talking about the polysaccharides. Okay. So they are having some functions, like they play a role in the storage. They play a role in the structure. Right, there are some storage polysaccharides, there are some structural, like if I talk about the structure में cell wall, the part of structure, cellulose is there, so what is that cellulose? What is that cellulose? That cellulose is also a polysaccharide. That cellulose is what? That cellulose is also a polysaccharide, right? So structure में it is playing the role. Chitin, the making the exoskeleton of the insect. Chitin present in the fungal cell wall, structural. When it comes to the storage, starch, stored food in the plant is what? It is starch. So it will be the part of storage polysaccharide. Your glycogen in our case, which is known as animal starch, again the polysaccharide. Getting it? Getting it? So this is what we need to discuss here, right? So as per their function, they are the storage polysaccharide, the structural polysaccharides, but we need to categorize them into another different groups, right? So polysaccharides may, there are two things. One is homopolysaccharide and the another one is heteropolysaccharide. Clear, bache? One is homopolysaccharides and the second one is heteropolysaccharide. Homo and hetero, right? Homopolysaccharide and the, yes everyone, heteropolysaccharide. Are you getting it? So when it is homo means same, hetero means different. Homo means same, hetero means different. Now they are, no doubt they are polysaccharide, they are present in that acid's insoluble fraction, but homo means this polysaccharide is made up of all the, here all the monosaccharides are same. This is the meaning of being a homopolysaccharide. Homo means same, that it is made up of same monomers. It is made up of same monosaccharides. Are you getting it? That is the homopolysaccharide. Now when it is hetero, right? So the different types of sugars are there. Are you getting it? Hetero means different. Hetero means different. So now when you talk about the homopolysaccharides, you have the examples of, yes, very common examples. They are glycogen, which is also known as animal starch. Okay, we have glycogen, which is also known as animal starch. It is the stored food in our case. The starch itself, plant stored food, right? The cellulose, which is a beta polymer. The inulin, again the playing role in storage. The chitin, they all are what? They all are homopolysaccharides. What are they, bache? They all are homopolysaccharide. Yes or no? Yes or no? Now when it is the different heteropolysaccharide, so it contain different monosaccharides, isn't it? It contain different monosaccharides. So now some students were saying na the examples of glycoproteins and all. So they are the part of this heteropolysaccharide, isn't it? They all are going to be the part of these heteropolysaccharides, right, bache? So your hemicellulose, it is again heteropolysaccharide made up of different sugars. The pectins, the hyaluronic, leave it, the heparin, the mucopolysaccharides. Mucopolysaccharides are also the example of your heteropolysaccharides, right? Right, bache. Heparin, you know na, heparin is a natural anti-blood coagulant. It is also the example there. Clear, bache? It is also the example there. Your hyaluronic acid is also the example. Do you know about hyaluronic acid? Yes. Do you know about hyaluronic acid? Anyone? Hyaluronic acid. Anyone? Hyaluronic acid. Anyone? Yes. Hyaluronic acid. Anyone? Do you know about it? Yes. Do you know about it? Huh? Do you know about it? Tell me. Hyaluronic acid, very common it is. In many shampoos these days, na, you see that they are enriched with hyaluronic acid. It is very good for the beauty as well, right? That cheek uplifting and all. In that case also, you know, they use the cosmetic surgeons, they even use this hyaluronic acid, right, for that lips filling and uplifting. I don't know that process in detail, but yes, this is the case. Hyaluronic acid in the in human reproduction chapter also I was telling you about it. Basically it's a cementing material, right? Like in our case it's the animal cementing material, right? Cementing material, like it is going to help in the joining of many cells together. So it is animal cementing material. What is it? It is animal cementing material. So basically it is going to help in the joining of the different cells together, and it is good for the vital beauty as well. And yes, you know that extracellular matrix and all that things. Basically it is for the cementing, it is for the joining, your hyaluronic acid, right? Now heparin, you know that it's a natural anti-blood coagulant. It is present in our case. Right, it is present in our case. Hemicellulose and pectin, you know that it is present in the plant cell wall. And when you talk about the mucopolysaccharides, right, you know that you have the examples of peptidoglycans here. Peptidoglycans are also the type of mucopolysaccharide. Your agar-agar that we get from algae, agar-agar that we get from algae, they are also the mucopolysaccharide. So what is the meaning of a mucopolysaccharide? Mucopolysaccharides are the polysaccharides having water holding capacity. They are the one that can retain water, right? They can retain water, they can hold water. Just say agar-agar, a powder. You will add the water, it will become jelly like this. Clear? Like this. So yes, examples are important. You should know which one is homopolysaccharide, which one is heteropolysaccharide. This is very important. And in detail, yes, we are going to talk about these examples. Clear, bache? We are going to talk about these examples. So we are going to start with the cellulose. Fine. We are going to start with the cellulose. Then we will read it from NCERT as well. We will revise it from NCERT as well. Don't you people worry. Okay. So what do we have? We have the cellulose. What do we have? We have the cellulose, right? Cellulose. So you know that cellulose is present in the cell wall, present in plant cell wall, yes or no? It is present in plant cell wall, yes or no? It is present in plant cell wall, yes or no? Yes or no? Cellulose. So cellulose is a linear, unbranched, it's a linear unbranched polysaccharide. What is it? It's a linear unbranched polysaccharide of glucose. So you know that na, it's a homopolysaccharide. It's a homopolysaccharide. So ultimately it is made up of glucose only. It is made up of glucose only, right? But which glucose is there, bache? It's the beta glucose. Which glucose is there? It's the beta glucose. Are you getting it? So no doubt, so many glucose, they will join together and they are going to form the cellulose, right? But it's a linear polymer of beta glucose. Okay, it's a linear polymer of beta glucose. So which glucose will be there? Beta glucose. And you know it very well, left end is going to be non-reducing, right end is going to be reducing. So you can expect here the glucose number is near about, you know, 6,000 to 11,000, right? In between 6,000 to 11,000 glucose will join together and they will form the cellulose. So this point is very important, bache, that it is linear, unbranched. Okay. It is linear, it is unbranched. Clear? It is linear and it is unbranched. This is important. Fine. This is important. Clear, bache? Cellulose. Cellulose. So obviously, what will it contain? It will contain beta 1,4 linkage. Right? And obviously, beta 1,4 linkage, basically we are talking about which bond here? Glycosidic bond. So ultimately they all are going to form with what? They are all are going to form with the glycosidic bond, right? They are going to form with the glycosidic bond. Is that clear? Now you know that cellulose cannot be digested in our body. Do you know that? Yes. Are you aware of it? Yes or no? The cellulose cannot be digested in our body. Do you know about it? Yes or no? Quick. Quick. That cellulose cannot be digested in our body. We cannot eat the raw grass because we do not have the cellulose digesting enzyme. So if we eat anything, you know, plant material, we need to cook it. Why? Because we do not have the cellulose digesting enzymes. Cellulose is a beta polysaccharide. Right? Cellulose is a beta polysaccharide. It is having beta glucose, and in our body we have the carbohydrate digesting enzymes, carbohydrate digestive enzymes, right? But that digesting enzyme is basically for the alpha polysaccharides. It is not for the beta polysaccharide, it is for the alpha polysaccharide. Are you getting this point? Cellulose. Right, so cellulose, which is present in the plant cell wall, will help in the plant pulp formation and all, linear, unbranched, having 6,000 to 11,000 monosaccharides unit. So it is made up of glucose. So beta glucose is there, beta 1,4 linkage will be there. Any doubt, bacho? Yes, any doubt? Tell me, any doubt? Quick. Pakka? Do you have any doubt here? Yes, sure. Then I'll explain the next part. So next is, right, one student is asking me again and again. Firstly, let me discuss that. Inulin. You know, in 2020, one question was there on the basis of this inulin. Many times students, they confuse it with insulin. Insulin is a protein hormone. Let me write it here. Right, when you talk about the insulin, insulin is a protein hormone. That is a protein basically. That is a protein basically. Remember pancreas, insulin. But when you talk about the inulin, inulin is a polymer of fructose. It's a polymer of fructose. So many fructose will join together, will form inulin. Inulin is again unbranched. And here also glycosidic bond is there. But that is going to be beta 1,2. That is going to be beta 1,2. Is that clear? Which bond will be there, bache? Beta 1,2 glycosidic bond will be there. Done? So inulin, and it is important. I hope you know that it is present in the, it is also a storage polysaccharide. It is also a storage polysaccharide. So it is used to check the GFR. Right, and what is this GFR? That is glomerular filtration rate. What is it? It is glomerular filtration rate. Fine, it is the glomerular filtration rate. Yes, you are right. In Dahlia's root, you will find it. In Dahlia's root, you are going to find it. Clear? So this is the inulin. What is it? It is the inulin. Now next is bache glycogen. So I hope you know about the glycogen, right? I hope you know about the glycogen. Yes. Do you know about the glycogen? Glycogen, also known as animal starch. Okay, it is the stored food in our case. It is also a polysaccharide of, or it is also a polymer of glucose. It is also a polymer of glucose. Clear, bache? It's a polymer of glucose, but this structure is branched. It is not linear. It is not unbranched. It is branched. That is what you need to remember. What is it? This glycogen is branched, right, bache? This glycogen is branched. Clear? Clear, clear, clear? Yes. Okay, so it is the stored food. It is also a storage polysaccharide. Even in the case of fungus, glycogen is the stored food. You can write down this point. Even in the case of fungus, it is your glycogen which is the stored food. So it is branched. Now, whenever you talk about any branched polysaccharide, let me tell you. So ultimately it is the glucose which is present there. Let me show you this thing. See, ultimately you know that the bond formation will be there. The glycosidic bond formation will be there, yes or no? Do I need to explain it again, or you know it? Or you know it? Ultimately the bond formation will be there, Sushila. So it is the 1,4 linkage. In the straight chain, it is the 1,4 linkage. Right, first carbon, fourth carbon, first carbon, fourth carbon, first carbon, fourth carbon. Right, so in the straight chain, right, I told you it is branched, but when there is the straight chain, so at that time you people are going to see 1,4 glycosidic linkage, right? Alpha 1,4 glycosidic linkage. At the point of branching, the linkage will be 1,6. Okay, the linkage is going to be 1,6. Let me explain how. So obviously here you people will have CH2OH, the sixth carbon. Here is the point. Let's say here is the point at which the branch will form. Okay, so I hope it is clear to you all now. Now, here, this is the first carbon. This is the first carbon. This one is the sixth carbon, isn't it? This one is the fifth carbon and this one is the sixth carbon. This one is the first carbon. So, obviously, now the bond formation will occur here. At this point, there will be the minus H2O. Yes or no? At this point, there will be the minus H2O. First of all, tell me, are you able to understand it? Yes. Are you able to understand it? First of all, tell me. Are you able to understand it, guys? Be quick. Yes, everyone, be quick. I hope you are able to understand it. So obviously when there is the dehydration here, okay, when there is the dehydration here, first and the sixth carbon will be considered, na? So 1, 2, 3, So that's how the bond will form. 1, 2, 3, 4. And somewhere that's how the bond will form. Yes or no? Yes or no? Yes. Tell me yes or no? Of course. Wait. So this is it is CH2OH, na? CH2OH. So it is taking part in the bond formation. and here also you are having H2O, so obviously here you will get the H. I hope now it is clear to you all. So this is the, so at the point of branching, you will see alpha 1,6 linkage. Okay, so it is going to be alpha 1,6 linkage, right? Alpha 1,6 linkage. See, 1, 2, 3, 4, 5. I'm not talking about the number here. Now it's a straight chain. So as I said, in a straight chain, what will you get here? Alpha 1,4 linkage. Let's not talk about alpha. 1,4 linkage is there. Now this is the point at which you will see the branch. So obviously at this point only you will see the 1,6 linkage. You guys are going to see the 1,6 linkage. Yes or no? Yes or no? 1,6 linkage will be there. Then again, let's say it is joining like this. So again it is a straight chain. Here it is a straight chain. So again 1,4 linkage will be there. So wherever the branch will arise, like if it is like this, wherever the branch is going to arise. So at the point of that branching, you will see the linkage is 1,6. Clear? The linkage is 1,6. Is that clear? That is your glycogen, which is highly branched polymer. Okay, which is highly branched polymer of glucose, of course. Okay, highly branched polymer of glucose. Done, bache? Done? Any doubt? Any doubt? Sure? Sure? It is glycogen. Let me check the diagram. See, in the NCERT they have given this glycogen, na? See, 1,4, 1,4. So at the point of branching, this is how they are showing. So here you guys are going to see 1,6. Okay. So that's what you need to remember. Fine, I have added the diagrams for you. So see this. Any doubt? Yes, any doubt? Okay, it is attached to the carbon. So, acha. But ek minute. 1, 2, 3, 4. Okay, my bad. Done, bache? Okay, so 6th, 1,6, and here 1,4, 1,4, 1,4, and 1,4. Done? Clear? So next is, and see, it is highly branched. Okay, it is highly branched, you all can see. Okay, so I'll share the notes in my Telegram group. Okay, I'll share it in my Telegram group. You can join our official Telegram group, Unacademy NEET English, and you can join my personal Telegram group. That is your Love Biology by Ambika. Okay. Clear, bache? Okay, so let me rectify this. Fine. Okay, so the next is starch that you need to understand. Next is what? Next is starch that you need to understand. So when you talk about the starch, starch is also a polymer of glucose. Now you know that starch is the stored food. It is the stored food in the case of plants. So starch is also a branched, right? It is also a branched, right, polymer of glucose. But in the case of starch, you are going to discuss two different things. Okay. In the case of starch, we are going to talk about the amylose and amylopectin. Fine. So it is the product of photosynthesis. It is the stored food here. Done, bache? So as I said, in the case of starch, what you need to discuss, you need to talk about two things. One is amylose and another is amylopectin. One is amylose, another is amylopectin. These are the two things that we have. Amylose and amylopectins. Amylose and amylopectin. Now, when you are talking about the amylose, amylose is unbranched but helically arranged. It is not branched, but it is helically arranged. Ultimately, they all are made up of glucose. And when you talk about the amylopectin, it is branched. Okay, it is branched. Now, many times na students, they get confused. Actually, your starch is made up of these two things, these two forms, amylose and amylopectin. Amylose and amylopectin. Now, this amylose is unbranched but helically arranged. As I said, it is branched. Right now, what is the meaning of this? Okay, so let's say this is a Now let's say this is a wire, okay? This is a straight chain, okay? This is a straight chain. Are you getting it? This is a straight chain. Now, this straight chain, it is not branched. Now, I can arrange it like this. I can arrange it like this. I can just coil it, yes or no? It's straight, but I can coil it. Right, so same is the case with the amylose. It is unbranched. It doesn't have branches, but it is helically arranged. A straight structure, you are coiling it. Got it? Got it? And amylopectin is branched, not as branched as your glucose. Not as branched as your glycogen, but yes, it is branched, bache. It is branched. So if it is branched, amylopectin is branched. So obviously, it will have 1,4 and 1,6 linkage, yes or no? It is going to have 1,4 and 1,6 linkage at the point of branching. Amylose, it's linear but helically arranged, so it is having 1,4 linkage only. Okay? Okay, but ultimately they are the starch. Let me show you the diagram. See, so it is amylose, straight it is, so linkage is 1,4, and here in amylopectin, right, you at the point of branching, you will see the 1,6 linkage as well. So they together, they are forming the starch. Okay, together they are forming the starch. Is that clear? Yes, bache, is that clear? So amylose is basically 20 to 30%. Amylose is making 20 to 30% of starch, and 70 to 80% is your amylopectin. Clear, bache? 70 to 80% is your amylopectin. So we can say that in the case of starch, right, in the case of starch, the ratio of amylose and amylopectin is 1:4. Isn't it? It's 1:4. So amylose and amylopectin. Amylose is and amylopectin. So major portion is of this branched amylopectin. So all in all, we say that starch is your branched. Okay, it's a branched homopolysaccharide. Clear, bache? It's a branched homopolysaccharide. And now, because amylose is helically arranged, you can you know that it can trap the iodine molecule. Right, it can trap iodine molecule. That is why in the presence of starch, when we add the iodine, what type of coloration will be there? Blue coloration. So it is the amylose which will give blue coloration. Amylopectin is still going to give red coloration. So ultimately, how is it possible? Because in the case of amylose, right, it is in the helically arranged, so it can trap the iodine molecule and it will give the blue coloration. Fine, it will give the blue coloration. Clear? That is a very important question. Fine, bache, that's a very important question. Done. So the next is your chitin. Very important. Next is your chitin. Chitin. So many times students, they are confused. Bache, chitin is a homopolysaccharide. What is a chitin? Chitin is a homopolysaccharide, but it is having N-acetyl glucosamine. Okay. So monomers are of N-acetyl glucosamine. So it is the amino sugar. Right, it's the amino sugar. So basically, so many N-acetyl glucosamine, they are going to join and they are going to form the chitin. Right, they are going to join and they are going to form the chitin. So chitin is what? Chitin is a homopolysaccharide. What is the chitin? Chitin is a homopolysaccharide. Clear, bache? Yes, is that clear? Sure. Sure. So as I said, it's a homopolysaccharide, and you know that it is also known as fungal cellulose, because it is present in the cell wall of fungi, and bache, even it is present in the exoskeleton of your insects. Okay, so exoskeleton of arthropods is basically having the chitin. So it is the N-acetyl glucosamine, and do you know it is the second most abundant organic molecule on Earth, this chitin. It is the second most abundant organic molecule on Earth. The word is organic molecule. Okay, second most abundant organic molecule on Earth. Any doubts? Yes, bache, do you have any doubts here? It is the second most abundant organic molecule on Earth. So it is NAG, N-acetyl glucosamine. It is N-acetyl glucosamine. Clear, bache? Clear, bache? Right? So even it is linear, like straight chain, and beta 1,2 linkage is there. Fine, beta 1,2 linkage is there. Beta 1,4 linkage is there. Chitin it is now. Okay, so that's all. So you need to remember the examples. Fine, you need to work on these examples. Fine, bache? Fine. So I hope, yes, we are done with this carbohydrate part, and I think it is the major part here. Right, it is the major part here, because lipids not so lengthy, proteins not so lengthy. Nucleic acid is going to take time, because we need to understand it in a good way so that we can, retain it. We need to even understand the molecular basis of inheritance. Fine, bache? And even enzymes is going to take time. So for today, we are going to complete the carbohydrate portion only, right? I didn't expect that I'm going to take it for so long. Right, I was fully prepared for the amino acids and all, but okay, we will discuss it in next class, because you need revision for the carbohydrates. Okay, that is the main reason. You need a revision for this. Okay, so that is why today we will discuss, we will cover the carbohydrates. In the next class, it will be a detailed marathon, and we will complete the next part. Okay, so this biomolecule chapter, I think this biomolecule chapter, it is going to take time. I'm not saying that I will take it in 3 parts. I will take it in 2 parts, but we have to go slow. I cannot be very fast, right? And after this class, you please revise it. Either I'll keep the class on Sunday, or tomorrow I'll let you know about it. Most probably I'm going to take your class on Sunday. How to watch hidden videos, right? But I don't know. If you will get to know, please tell me. Ma'am, color कैसे रहते हैं? कौन सा color बच्चे? कौन सा color? So ये revise करना, just revise it. Okay? Please revise it. Done? So sure you are going to revise it? Promise? Promise? So that video, this video is more than sufficient. Now what you have to do, you need to practice the question. Like they can ask you that if it is a branched polysaccharide, how to calculate the number of ends? Number of branches -1, something like that. So start practicing the questions. Okay, chitin is linear. Linear means unbranched, of course, straight chain. Any other doubt? Sure. So I just request you people to put one comment, right? If you like the session, please mention it in the comment section, and which chapter you want to start next, even put that in the comment section. And as I said, bache, this is something very important for you all, right? This video in 15 minutes or in 10 minutes, you guys can see this video. Just check it out. This video is going to be very useful for you, and I told you to increase the likes here. It should be 60. It's still 56, but okay, anyhow. Okay, now the next another important point. Wow, now it's, oh, okay, thank God. So बोल के मैम आप भी please time को see, if you have problem with all that ना, right, I cannot help it, literally I cannot. So now see bache, in the description box, what you people need to see? First of all, the link for All India mock test is there. Even if you are the part of any offline coaching, okay, or you are the part of any other online coaching, you need to go for the mock test. Practice as much as you can, and that test should be NCERT based. So our All India mock test series, right, it is NCERT based. So what you need to do, you just need to click the link. add your number or email. So see, today you are going to get it at a price of 999. Few days tomorrow, yesterday, basically, yes, yesterday or I think for 1 month it was for around 1499, but now it is 999. Right? In 1,000 rupees, you can solve 20 plus tests, plus detailed discussion sessions are there. You can ask the doubt from your teachers, bache, right? After every test, there will be the detailed discussion session also. So join it now. Join it now. Again, the price will reach to that 1499. So please save your money and be the part of it. And if you are looking for a batch, because so this is the NEET Energized batch. The link is given here. Click there and be the part. And let me tell you, bache, in my batch from 1st of August, I am going to start plant physiology and then human physiology and then genetics. So in coming 2 months, we are going to finish the most scoring part of the biology. Okay, so don't waste your time. Come and join the classes and be regular, and do watch this video. Fine? Do watch this video. So take care. Bye-bye. Tada. I'll share the PDF in the Telegram group. So in the comment section, do let me know, bache, how's the session. And moreover, what you have to do, you need to tell me that which chapter you want me to start next. Okay? And I'll take one poll for it too. So accordingly, we'll go. Fine? Done? So I'll share the PDF in the Telegram group. So take care. Bye-bye. Tada. Please put a comment. Thank you so much. Stay tuned. Do subscribe our channel.